Okay, that's okay. That's okay, Anna. Okay, so what I want you guys to do, have a paper. Okay, have a paper. Write down on the paper to unit 1. What are the things? So whatever we discussed today, I want the notes on that. If you already know this, you don't have to write down, but what are the things that you kind of like forgot? I'm sure you already know it. It's just like what you forgot. You want to write down there. So tomorrow, before the test, you don't have to go and read the whole book, right? You can just go over these notes and see what you need to review. Okay? So, first thing, okay, mole smaller mass. There's nothing to do here, right? Mole smaller mass. Everyone knows how to convert from grams to moles to, right? And into number of atoms, Avogadro's number. There's no question here, right? Any question? Any question on this? I hope no, right? Okay. So if you have, for example, in this one, if you have okay, this one. How would you do it if you have grams and you want to find the molar mass? Identify the metal. What do you do? Go ahead, think. I don't need you to do the math. I want you to, I mean, like if you are someone that is fast, you can go ahead and do the math. Go ahead, do the math, or else I just want you to tell me what do you do. In this case, I want you to be able to just let me know what is the plan. Go ahead, someone. Yeah, Madhav.
So like the atoms given, so like you divide
Uh-huh.
the Avogadro's number to get the moles of the metal, and then you
Good.
divide the mass of the metal by the moles of the metal to find the
Good job.
molar mass.
Very good. Yes. Everyone get it, right? You convert this into mole, and then you know that molar mass is gram per mole. You get the molar mass. Check who has the molar mass. Same. Okay, anyone got the answer? Yeah. Just speak up. Okay, I do not have time to just speak
I
up.
got 112.
Uh,
So
yeah,
just add one.
yeah.
Yeah.
Okay. So those who think they already know, just do this as practice, okay? Keep doing. And I'm just okay for mass spectra for this one. Just already know. I'm showing you guys the question so you can do it, okay? For mass spectra for this type of question, what do? You just do average atomic mass equals to mass of 1, abundance of 1 plus mass of 2. No, depending on the number of isotopes. Now, what is isotopes? What is isotopes? Just speak up. No raising hand anymore. Just speak up. And I don't want to hear. I'm not asking question. Answer. I don't want to hear. So just the same voice every time. Okay. So I want everyone to speak up. Okay. So what is isotope? That's my question. What is isotopes?
Same element, different number of neutrons.
Same number of.
Same element, different number of neutrons.
Okay. So when you have same element, you have same number of what?
Protons and electrons.
Okay, you will have same number of proton. Proton is the identity. So isotope, same number of proton. Write down. Whoever forget what is isotope, write down. Okay. If you already know, if this is like common sense to you, you don't have to write it down. Isotope, same number of proton, different neutron, or same number of atomic number, different molar mass, right? Those are, sorry, not molar mass, atomic mass. And those are what? Those are isotopes. If they gave you this mass spectrum, how do you know mass spectrum? We already talked about this. You look at the X and Y. If this is mass, this is what? This is abundance. That means this is mass spectra. So how do you get the average? You can do what? So how many isotopes you have? 1, 2, 3, 4, 5. So you have 5 isotopes. So keep going on to 5. take the mass, multiply with the abundance. Now in abundance, make sure to put it in decimal, do not put it in percentage, okay? Put it in decimal so you don't have to go ahead and divide by 100 anymore. Okay, just put into decimal and then you're gonna get your average atomic mass. And that's how you do this type of question. Okay, now because they already say this is what? This is germanium, right? So sometimes the other type of question they might ask you, is that they're gonna give you the average atomic mass, but they're asking you for percentage, the abundance. What do you do in this case? So it's not the same person answering. Lisha, you already have the average atomic mass. You have that say average atomic mass is 53.5. The first isotope is 52. The second isotope is 54. What do you do in this case? How do you get the percent?
Do you
Lisha,
like substitute like how I do is I like substitute a variable for it and then I find it.
how would you substitute X and Y?
Well,
You cannot have two variable. So
oh, okay, you don't have the percent abundance for any of them. So you would just
none. Because if you have one, you can just do what? 100 minus that,
yeah.
right?
Mm.
So you have none of them, but you do have the average atomic mass, the answer. You have each of the mass. What do you do? What do you multiply? One of them would be X, the other
X
would
and
be
then
1 minus
1
X.
minus X. Okay.
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 Makes sense? I'm not gonna do the math, okay, guys? We really don't have time to do the math. I'm just gonna go over like how to do it. Any questions so far? Okay. And then this type of, okay, sometimes instead of what? Instead of giving you, see, they're asking for neutron. What is neutron? Well, you know what? Neutron is the mass number minus number of proton, right? Super simple. So once you have the most abundant is which one? Is that what they're saying? Right? Yeah, 74 is the most abundant minus the number of proton of germanium, and then you're gonna get the answer, which is 32, right? And then you're gonna get 42. Read the question. Okay, do not assume you already know what they're asking just because, oh, they're probably gonna ask me to find the average mass. When in fact, they already gave you the element. Whenever they give you element means you already know the average mass. Okay? So now how do you do number 7? Oh, sorry, number 4. Please, please, fast. Do it. Go ahead, do it. Do you already have it? Ananta?
Yeah, so what I did here was that you already have antimony on the period table and it's 121.76 is the average. So you know that the 121 mass will be a little bit larger than the 123 because if they were
What's
both
the mass?
equal,
What's the mass again? I'm sorry, what's the mass again?
121.76,
Okay.
which is closer to 121 than to 123.
Okay.
So it's either first of all, you can just ignore A and C because they're not mass or neutron count. And then when you look at B and D, D has a slight like increase on 121 over 123, and B has them both equal. So it's D.
That means the average must be a little bit to the, because between this it should be middle, right? But because this is longer, more it should have been towards the left, right? Okay. Make sense? Any question? That's okay. No, everyone can ask question. Okay, if you have any question. Okay, Sharvari, Inaya. Okay, this type of question. See, whenever you are given, see, whenever I didn't even read the question, okay? You guys can do though, but I'm trying to just like give you the overall concept, okay? Whenever you have the carbon dioxide and water, Okay, you first go find the moles of carbon from the carbon dioxide. Okay, and then from there, you're going to get your moles of carbon. From water, go find the moles of water. From moles of water, go find the moles of hydrogen. And then do the empirical formula. Do you guys remember the empirical formula? Empirical formula. So empirical formula, what do you do once you already have? Okay, now look at this. For this one, let's say this also contain oxygen. Let's say this element also contain oxygen. Okay, and they also give you the total gram. Let's say they give it the total gram is 16 gram. I'm just making up the question, okay? This is not the question what I'm talking about, but let's say I'm just making this up. Once you have moles of carbon, you're gonna go to the grams of carbon. Same goes here, you're gonna go to the grams of hydrogen. And then from there, how do you get the grams of oxygen? You take the total grams of the compound, you subtract with the grams of carbon, you subtract with the grams of hydrogen, you get the grams of oxygen. Does it make sense? Does it make sense? Let's say you have what? You have a compound that contains carbon, hydrogen, and oxygen. They give you the mass of carbon dioxide and water. And they ask you, can you tell us what is the empirical formula of this compound? What do? From the grams of carbon dioxide, get to the grams of carbon. From the grams of water, gets to the grams of hydrogen with this steps. Once you have the grams of carbon and hydrogen, you subtract these two numbers from the total gram to get the grams of oxygen. And once you get the grams of oxygen, you can do empirical formula. Okay? You can do empirical formula. And then what is empirical formula? First, divide by the molar mass to get the what? The mole. And then once you have the mole, you divide by the lowest mole. Once you have the lowest mole, you're going to get the what? You're going to get the sum number. Let's say this is 1.33, this is 1, this is 2. You multiply with the number to get what? A whole number. So that is 3. So this is going to be 4, 3, 6. Any question, Veronica? Make sense? Okay. Madhav, make sense? Okay. And do you guys know if you're given with the molar mass, how do you get the molecular formula if you already have the empirical formula? Anyone? Sanvi? You have to get 100% on this, Sanvi. You have been studying this for like 6 months. Just unit 1. Okay.
Okay. But if you have the molecular formula, then you can divide the molar, and if you have the molar mass, you can divide it by the molar mass of the empirical formula, and then see like the number, and then you can multiply each of the subscripts that you used for
Okay.
the empirical formula, and then change that for the molecular formula.
Okay, good. Okay, same goes in hydrate. Okay, in hydrate, you just treat hydrate as another empirical formula question. But instead of break them down into their each element, you do what? On one side, you do MBR2, the salt, the other you do water. Okay, so for example, this one, when this is what? The hydrate, this is the total, right? And this is just the Mg. Anhydrous means what? No water. Anhydrous means no water. So MgBr2, this is 615. So water would be 9.76 minus 615, whatever that is. And then what do you do next? Divide by the molar mass, whatever the molar mass of MgBr2, blah, blah, blah. And then get the mole. And then divide by the lowest mole. And then get your This is going to be 1 for sure, and you're going to get some other numbers there. There will be never, if you not get this 1, that means you're wrong. You did your hydrate calculation wrong. This has to be 1. Any question? Okay, next. Okay, sometimes you're also gonna have this type of question where they're talking about impurity, right? So percent mass means what? Mass of something. Let's say you want to find the percent mass each of this. So mass of Na divided by molar mass of the total, whatever the compound is, times 100. And then you compare, okay? You compare who has what mass. For example, this one, I'm just making this up, okay? Numbers, I do not know the numbers. Let me see if I think okay. Okay, whatever let's say the percent, what's the percent mass of Na2? I think it's 32.4%, okay? So the percent mass of Na in Na2SO4 is 32, but you have what? You have impurity in it, and that sample contained this much of percent of Na. So which among these are the impurity? You want to check which one has lower percent mass of Na. That's why it actually lowered down the what? The total impurity and Na2SO4, when in fact Na2SO4 should be this, but because of the impurity, it got lower. Okay, so for example, NABR, if you check NABR, it is what? 22 point something something. So that makes sense that NABR, if NABR is the impurity, it's going to load down the 32.4, making it 29.5. Okay, other than that, all of them, they have higher percent. Configuration, do I really need to teach you guys configuration? I do not need to teach configuration, do I? Do I? You just have to look from the periodic table. Wait, let me see. I couldn't find my periodic table. Oh, there you go. Okay, so let's say you want configuration of titanium. Where is titanium? What do? This is S block, right? P, D, F, right? You go what? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. This one goes from 3. So 3, 4, 5. So 3d2. Right? 3d2. Okay, now the question that they might ask you is the configuration of ion. So if you have titanium, it's what again? Argon. Titanium is argon, 4s2, 3d2. If you want to lose 2 plus means you lose 2 electrons. If you lose 2 electrons, that means what? The electron's gonna go from where?
The 4 is 2.
And yeah, from the outermost, this 4 is outer on compared to the 3. Okay, so if you have 4, that means this is also gonna be gone. Do not write configuration like this. Okay? Do not like break it up. Even if you still want to do noble gas, you can, but you start from neon now. Okay? I have seen students do this. Start from neon. How do you know unpaired electrons? How do you know unpaired electrons? S has how many orbital? 1, P, 3, D, 5, F, 1, 3, 5, 7. 7 boxes, orbitals. 1, 2, 3, 4, 5, 6, 7. Now, what are the rules of to fill this orbital? First, you have to fill what? You have to fill them based on their energy, okay, which means the electronic configuration. Next, you fill one each before you start pairing. You cannot do like this. Okay, fill one each, and then you pair. Okay, so for nitrogen, you already know the noble gas. They all have full wet fill orbital. So neon, what's configuration of neon? Noble gas configuration of neon. Sharbari, fast. Noble gas configuration of neon. Araf, camera.
It's the
Anish.
S is filled, the P is
Noble
also
gas of no. Noble gas configuration.
like 1s1 2s2
Noble gas, the noble gas. Helium, right? Is it helium?
helium
And then
2s2 and then 2p6.
nitrogen is 2p6.
We have a question based on this.
Uh-huh.
So can I just like say like for like neon, 1s2, 2s2, 2p6, or like what's like wrong in like saying that?
No, you can also say that. It's
Oh,
not wrong. Okay, now this is can everyone confirm this is the configuration of nitrogen, right? Right? Yeah. Okay. Now what do? You know S has one box, one orbital. P has 3 orbitals, so just draw it. This is 2s, this is 2p, and then fill it up. 2, 3, but you have to fill it up once, one each. Okay. So this means this one has how many unpaired electron? 3. Okay. Selenium. Arab selenium, configuration of selenium. Noble gas.
It would be, wouldn't it just be,
Someone fast. Configuration, noble gas configuration of selenium. I do not have periodic table. Just say it. Sanvi.
Argon in brackets,
Argon in bracket.
4s2, 3d10, 4p4.
Okay, so for S2, if you draw 1, 2, D has 5 boxes, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. So how many unpaired? 2. Okay. Okay. Based on the electronic configuration, if they're in ground state, if they're element, if they're neutral atom, that means what? Number of electrons equals to number of proton, right? So sometimes they might give you the configuration. So from the configuration, but you have to make sure they are element, okay? They are not ions. If they're element, number of electron and proton the same. So from here, you know that, okay, the second one, right, has more proton. So because it has more proton means what? It's going to have more attraction, right? First, what do you use? Okay. Let's see. For periodic trend, please write it down. This one, I need everyone to write it down, no matter how smart you think you are. Periodic trend. First, whenever you do periodic trend, you first compare the shell. Do not go like check the charge, no matter if it's aluminum versus aluminum 3 plus. Always go check, compare the shell. Okay, first compare the shell. This one I need to be in your notes that you can review tomorrow. First compare the shell. So even if it means you have to spend 10 seconds to figure out the electronic configuration. The one that has more shell, bigger. Why is it bigger? Because the distance between nucleus and the outermost shell higher, the Coulombic attraction go down, and the size become bigger. Always talk about Coulombic attraction. Okay, Coulombic attraction is a must. Once you compare the shell, if you see both of them have the same number of shell, then what do? The second, you compare the proton. Don't directly go compare the proton. You have to compare the shell first. Only if the shell are the same, then you compare the proton. The one that has more proton means what? Higher Coulombic attraction, smaller, or if it's smaller, more electronegative, whatever that is, whatever trend they're asking you, higher ionization energy, blah, blah, blah. And if the proton also the same, so for example, like different ions, like Al2 plus versus Al3 plus, even when protons also the same, now you check the electrons. More electrons, higher repulsion. More electrons, higher repulsion, bigger will be the size. This is how you check your trend. Do not directly go to the this. Because if you say, okay, I'm looking at this too, I see aluminum is having less electron, that means it's gonna be smaller. It is smaller, but your justification is wrong. If you check the configuration, you would see that actually what this is in second shell. That means you should have compared the shell first. Okay. This is just what? This is just the height is the height is the number of electrons, and then you have what? If it is more to the left, that means the binding energy is more. If it's more to the left, binding energy is more. If binding energy more means Coulombic attraction is more. Okay? More to the left, binding energy more binding energy, Coulombic attraction is more. Okay, let's say they give you two different, sometimes they also give you like this. Oh, I think this is the one that okay. This is the one, the question. Okay. So they say that these two is of 1s. Okay, this is not 1s and 2s now. This is 1s of two different elements. It's either fluorine and neon. Okay, this is the 1s of fluorine and neon. This is also 1s, this is also 1s. Which is which? You know, again, you go back to what? You go back to the shell, proton, electron. So you see that the number of shell, same for fluorine and neon. Then you go to the number of proton, you see neon has more proton. So more Coulombic attraction. So binding energy is more. So which one has more binding energy? The X or the Y? Veronica, X or Y?
X.
Good. X has more binding energy, so X would be the neon. Okay. Okay. We talk about periodic trend, right? The periodic trend, those three things, every periodic trend, that is how you should do. Compare the shell, compare the proton, then compare the electrons, if they are tie. Okay, now, this is ionization energy question. You check which one has the highest gap. Okay? Because the fifth one has the highest gap, the valence electron will be the fourth one. I mean, like, not the fourth one. That means it has 4 valence electron. The concept here, let's say you have what? I don't know how I'm gonna cover 9 topics today, but let's see. Okay, so you have what? If you have 4 valence electron, right? Think about this. You're going to, oops. The first ionization energy means what? Energy needed to release electron from the atom. Think about this. If you have to take out this one, right? It's pretty easy because it's on the valence shell. Easy to take out. The next one also pretty easy. The third one also pretty easy. The fourth one also pretty easy. But guess what? If you are trying to take out this one, the fifth one, it will take a very high amount of energy. That's what you see. High jump of energy. Okay? Make sense? And I think that's it. Okay. Here. We already done periodic trend. Okay. That's it. Unit 1 done. Unit 2. Okay, unit 2, Lewis structure. I don't have to do Lewis structure, right? Ionic bonding, metal, non-metal. So how do you guys get the polarity? Well, you want to remember the highest polarity is fluorine. The trick here is that the far away it is from fluorine, the less electronegative it is. If it's very near to fluorine, it's more electronegative. Okay, fluorine the most electronegative, followed by oxygen. So highest polarity would be, wait, highest polarity, if they're asking you highest polarity, that means the one that are far away. But treat hydrogen like a sulfur. Wait, is it sulfur? Yeah, wait, is it sulfur? I think so. Treat hydrogen like a carbon. Okay, put hydrogen position in carbon or sulfur. Okay, this one. So this point is the highest repulsion point because the atoms are very close together, proton-proton repulse, right? This is the most stable point. This is the most stable point. If they're asking you for bond energy, this point is where you're gonna get your bond energy. But make sure take the absolute values, so 250. For the bond length, this is 200 picometer. Okay, number 7, who do not know how to do this? Read the question, please. You compare the charges first, okay? If it's ionic bond, these are what ionic bond. Coulombic attraction of the ions. Check the charges. The one that has highest charges, both of them, that will be highest Coulombic attraction. Okay, and then how do you break the tie between this? The lower the size, the higher the Coulombic attraction. So A. The lower the size, the higher the Coulombic attraction. This one, just remember, make sure to know which is smaller, which is bigger, right? What are their charges? Okay, types of type of solid. Ionic, covalent, network, molecular, and metallic. Okay, someone give me, how do you figure out something is ionic? Let's say they give you something. How do you figure out something is ionic, Anish?
You could dissolve it in water and test its electrical conductivity, or you could see its high boiling point, but electricity would be probably better.
Electricity would be better because high boiling point, this high boiling point. Metallic, some of them have high boiling point, right? So the electricity is the one definite test for ionic bonding, ionic salt. Why? Because in solid, it does not conduct electricity. In liquid or aqueous, it conducts electricity. Okay. What do you call that? What's the what will be the info that you need to see for something that is COVID and network?
No boiling point, like very high boiling point. It won't conduct electricity.
Very, very high boiling point, melting point.
Yep.
Okay, like it's not comparable to ionic. Ionic is high boiling point, but not comparable because it's going to be very high. An example of covalent network, so ionic would be what? Metal and non-metal. Covalent, diamond, quartz. If you see like silica, silicon dioxide, whatever molecular, it says non-metal with non-metal. This molecule, we're basically talking about IMF, okay? We're not talking about the covalent bond. We're not breaking the hydrogen and oxygen bond inside water. You're breaking the IMFs. So for molecular, what do you need to know that, oh, this is molecular? Go ahead, someone. Yeah. Yeah, Araf.
They have high thermal energy and they're good electrical conductors.
They do not have ions. How can they conduct electricity? They're non-metal, molecular, not metallic. So no, not going to conduct electricity ever, not in solid, not in liquid, not in aqueous. Okay, not an electrical conductor. And the melting point, boiling point also low. What about metallic? What about metallic? How do you know something is metallic?
It can conduct electricity in its solid form.
Yep. It can conduct electricity in solid form. Okay, talking about metallic, there are a few characteristics of metallic that you want to know. That is what? Ductile and brittle. Wait, sorry. Who's brittle again? Brittle is ionic. Why is ionic brittle? Can anyone explain? Why is ionic brittle? Sanvi?
It's because they're like packed together tightly and then their charges are alternating. So when they move, like their charges start repelling.
Good. So it is brittle because think about this. This is positive, negative, positive. Ionic are brittle, okay? Not metallic. Metallic are ductile and malleable. This is metallic. They are going to ask you to justify why ionic is brittle. Okay, so if you can draw this diagram, it would be good too. And then explain yourself. Easy to explain. So, wait. Look at this, okay? Brittle means easy to break, right? If you just try to push it a little bit, what's gonna happen? This is ionic, no? If you try to push this, but think about this. What's gonna happen? Same charge going to face together. Same, repel, opposite, attract. So this is gonna repel, because why? You just push them a little bit towards this, they're going to start repel because they have same charge. That's why it's brutal. Malleable, okay, which one has C of electron? What does it mean?
Metallic has C of electrons.
What does it mean?
It basically means that like all the electrons are like around like the metal. So that's why it's like conductive.
Around the metal ions. Around the metal ions. Okay, good. Let me see. Oh, we were just talking. We were just talking about this, okay? Why this is? That. This is the sea of electrons. Oh, this type of solid. Which one is it in? How do you know something interstitial?
If it's in the small gaps between the metals.
If it's in, you are not gonna go see it, right? They're probably not gonna give
In
you
the
the
diagram.
diagram. If they do not give you the diagram, how would you know?
The one with the smaller atomic radius is the one that's going inside.
You want to
bigger
see
atoms.
the pair. To get the pair, you want to see the pair that are what? That are highest difference in size. You check the size difference. And how do you check the size difference? The shell, right? Remember the first thing? Periodic trend, go compare the shell. You check the shells. You check the shell, which one has the highest difference in number of shells. That's gonna be the one that is very small and very large. And if that's the case, the smaller one will go fit into the gap or interstitial. This is interstitial alloy. But if they're basically on the same shell, that means they're what? Their size are very comparable. That means what? They're going to substitute. Okay, so substitutional. Okay. Lewis structure. Okay, I'm not gonna go over how to do Lewis structure, okay? If you do not know how to do Lewis structure, you should not be taking the test on Tuesday. Okay, now, what we want to go over is that the exception. What is the exception of Lewis structure? First, the boron. Boron just need 6. So you're not gonna go do like this. This is wrong. Okay, this is wrong. Why? Because boron just needs 6, so you don't actually need. Why though? Why is, okay, let's say they did ask you this. Why is boron an exception? Who wants to try? Go ahead, Saket. Why is boron an exception? Why is BF3? They already told you, okay? BF3 is an exception to the octet rule. Justify.
Were you saying me? Okay, I got. It doesn't like, I don't know why, but it doesn't except like follow the octet rule.
Well, that's what the question said. It does not follow. It's an
Yeah.
exception. Why? Justify.
It's something to do with like the S and P. It's something to do with hybridization, I'm pretty sure.
Nope. Okay. Sanvi.
I'm pretty sure it's because boron only has 3 valence electrons. And I think it needs 6 to be stable.
Well, that's the exception, guys. That is the exception, that it only needs 6 instead of 8. The question is why. Let's see. Anish?
I don't know.
Really? No one's know? No Googling. Don't try to impress me. There's no point. Atarf? Oh, wait, is that Ananta?
It's because boron's a metalloid, so the
Nope.
bond forms. All right.
Nope. It's because of the formal charge. Because of the formal charge. Okay? It's because of the formal charge. Let's say you force it to be this double bond. Look what will happen. Now boron will have what? -1. Is that a stable formal charge? No. Okay? Because of the formal charge. So what are you going to say? Due to the formal charge, right? Due to the formal charge of boron and its valence electron being 3, right? But you have to mention, Sanvi, you're almost there, but you have to mention about the formal charge. Okay? So boron will likely to form 3 bonds, not 4 bonds. Okay?
Can you
The
repeat
key,
like the final statement again? I just want to like write it down.
because boron has 3 valence electron. Okay.
Mm-hmm.
And you can also write the formula of formal charge. Okay, now formula of formal charge, I know I keep saying wait, bonds minus dots, but the one that you want to write in a task as that formal charge is what? What? Valence electron minus bonded, half of the bonded pair, half of the bonded electron minus what? Electron, not electron pair, unbonded electron. Okay. Now you want to say because of the valence electron of boron being 3, right? So to accommodate the best formal charge and the most stable formal charge, boron has to form only 3 bonds. Okay, the keyword here, you have to mention the formal charge. Okay, to have the most stable formal charge. Okay. What else do I? Okay, find the formal charge here. And choose which is the best formal charge. Is this okay? Right? Just let me know if I did something wrong and my mind's not working properly. I'm trying to just do. Is this correct? Did you guys get this? Anish?
I got that.
Yeah? Okay, so which one is the best formal charge? If you have to rank.
It's A.
No, the one that all zero.
Wait, but shouldn't like the most electronegative atom in the
Oh, but the problem is what? Nitrogen can only accommodate how many? 8. Okay, nitrogen can only accommodate 8. So this nitrogen is accommodating how many? Oh, it is 8, right? 1, 2. See, my mind's not working. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay. This one, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so C, right? C is the answer, right? Everyone agree? Okay, Madhav, what you're trying to say?
Oh, like I was like trying to say that like I was thinking A because like the most electronegative atom in
Now,
the
if you can find something that's all zero, it will be the one all zero, but make sure if it's on the second row, it's not exceeding 8. It cannot exceed 8. Okay? So if it exceeds 8, let's say there is another dots here. That means it's 10 now. Now that's not gonna work. Okay? So if you say, okay, so this is the most stable, number 1, which is the second most stable now. And then your A comes in. Okay, which is the third most stable? Would be?
B.
And then this is the least stable. Well, it's a tie between these two. Okay. I think okay, resonance. The thing that resonance, you have to understand, when you talk about this, the bond. Okay. Is there gonna be resonance here or no? Go ahead, find the bond order. Is there gonna be resonance or no first? Yeah, Inaya?
Yes.
How many resonance total,
Two.
including this? Including
Oh,
this?
three.
3 resonance, right? Okay, now I give you A, B, C, which is the longest bond? Which is the longest bond? Sakit.
B and A are the same length.
B and A is the same length. Didn't we go over a question like this already? Ananta, which is the longest bond? This is how I know you are
which are really
not
further from the double bond.
ABC. ABC, which is the longest bond? This is how I know you guys are not paying attention. ABC, which is the longest bond? This is not our first time doing this. Okay, Prajin, which is the
Would it
longest
be
one?
neither? Would it be neither because they're all in
Good.
resonance?
Good. They all are resonance. So because they all are resonance, so basically what? Be sharing this bond. That's the thing. Pay attention. Expected more from you too. Because they're in resonance, what? This bond are actually being shared. That means all of them have the same length. Bonds that participate in resonance have the same length. Okay? Bond order. Go ahead, Sakit, bond order.
Bond order of any of them would just be
Good. Any of them would be?
1 plus 2 1. 4/3.
4. Why 4? Because you have 4 bonds divided by how many resonance structure you're gonna have? 3.
3.
4 over 3. Bond order. Okay? This is gonna go so. Okay, and then we already talked about the geometry yesterday, right? Things you have to remember. The hybridization. This is what? SP, SP2, SP3. You are not going to be asked SP3D2, sorry, SP3D and SP3D2. Angle 180. $120 and 90. And then this is 90. Now, which among this? Well, polar, non-polar. If you have, okay, question. If you have, okay, for example, if you have this structure here now. Is this polar, non-polar molecule?
Non-polar.
Why?
Because
Justify.
it's symmetrical and each of them have like the same polarity, so it cancels out.
Okay, good. Araf, you do not want to turn on your camera. You also do not want to answer. You ready for Tuesday, Araf?
Hopefully.
Okay, this one. Answer this. Is this polar, non-polar? Justify why. Araf.
Is it polar because it has the what's the shape? Trigonal pyramidal shape?
And then just that. Is that how you're gonna say?
And it has a lone pair remaining too.
You're not gonna get the point. You want to say that what? There is a asymmetrical distribution of electrons. Okay? Write down. How would you answer? If something is non-polar, you want to say asymmetrical distribution of electron.
Wait, isn't that for like when it's like polar?
Yeah. Asymmetrical distribution of. Or did I say non-polar? I'm sorry. I
You
meant
said
say.
non-polar.
Oh,
Yeah.
my bad. Polar. That means I mean polar. Okay. So when it's non-polar, wait, see, I keep doing it. When it's polar, there is asymmetrical distribution of electron. Okay. Now this one, is it polar or non-polar? Anam.
It's non-polar.
Okay. You guys know this thing you just have to remember. Okay, hybridization. How do you figure out hybridization? You just look at the electron domain, right? How many sigma pi bond? Each first bond gonna be sigma. So 3 sigma, 1 pi. Okay? Finally, unit 3. Okay, do you guys need break? Anyone needs break?
Can you go back to that last like loose structure that like you asked if it's like non-polar or polar? I just need to copy it down, that's it.
This one?
The last one, yeah. So CCl3F.
Anyone needs break?
I have
No,
a
right?
question on
Uh-huh.
CCl3F. Like, how is it non-polar? I just need to like get
Okay.
clarification from it.
So each of this bond, right? Well, the CCl3, this doesn't, the CCl bond, all of them have the same strength, right? Polarity.
Yeah.
But the CF bond is more polar. So this one is pulling more towards the right side. So it's not symmetrical 100% because this one is pulling more.
So it's gonna be.
It will be polar.
Oh, okay.
Okay, any question unit 1 and 2 before we move on to unit 3? Any
So
question?
the PCl4 then would be nonpolar, right?
Yeah.
Okay.
Anyone? No. Unit 3, IMF. Okay, so for IMF, what first? First what? The hydrogen bond, dipole, and then dispersion force. And then dispersion force everywhere depends on what? Size. How do you justify? Bigger molecule, bigger electron cloud. What? Easily polarizable. Okay? Bigger molecule. So depend on size. Higher, the bigger is the molecule, the LDF will be strong. What's your justification? This. When do you have dipole? We just learned how to figure out polar nonpolar molecule. Polar molecule is dipole.
I have a question.
What is?
So like for the LDF thing, so like suppose if you're like comparing like pentane and then like propane, right? So you just say that like pentane has like a more polarizable electron cloud
Yeah.
than propane.
Yeah. I gave it here, right? Yeah, basically what I just said.
Okay.
Okay.
I
Yeah.
just need to clarify on that. That's it.
Yeah. Hydrogen bond, unit 2. Hydrogen acceptor and hydrogen donor. What is hydrogen acceptor? The hydrogen acceptor is FON with lone pair. If you have, okay, question. Can this form hydrogen bond with itself?
No,
Can this form hydrogen? Why not?
because it doesn't have like the lone pair.
Yes. You do have hydrogen donor, which is what? Hydrogen connected to bond. You do have hydrogen donor. You have 4 hydrogen donor, but do you have hydrogen acceptor? No. No hydrogen acceptor because it has to be FON with lone pairs on it. Anish, you can lie down. I know you guys so tired. I know. Okay. Make sense?
Could you go over ion induced dipole and like
Yeah.
that?
Ion, what is ion induced dipole? Ion dipole. Oh, it's ion dipole. Well, it's just ion dipole, right? What will they ask you in ion dipole? The only thing they're gonna ask you in ion dipole is that you gonna have cation. If water is surrounding it, the oxygen gonna be facing towards it. If you have anion, the hydrogen part gonna be facing towards it. Oh, ion induced dipole. Oh, I'm sorry. This is ion dipole. Ion induced dipole. This is okay. This is what? Ion dipole. Okay. Now, if you have ion induced dipole, what does it mean? You have ion. Let's say you have something nonpolar. Okay, like what? Cl2. Now, because the Cl, you have 2 Cl, right? This Cl is what? Facing towards the C plus. That means what's gonna happen? The electrons on this Cl gonna try to be on this side. So this side will be a little bit negative. This is gonna be positive. So this is how the ion inducing dipole to this nonpolar molecule, which I don't think you guys need to know, but just still. Who's asking that? Make sense?
Yeah.
Okay. This is ion induced dipole. When the ion inducing the dipole moment on a nonpolar molecule. You also have which one is temporary dipole? If they say temporary dipole, what do they mean? Anyone?
London
Okay.
dispersion forces.
London dispersion forces. Just because they say, please listen, you hear dipole, you say dipole, dipole. No. No. Temporary dipole is London dispersion force. Okay, because London dispersion force can be what? Sometimes it's still gonna have something like dipole, but it's temporary because of how the electron cloud moving.
Is it because it's like the weakest form of IMFs?
Yeah.
Okay.
But sometimes, as we already seen in a lot of questions, also you might get this type of question where you see the LDF will have stronger IMF compared to dipole-dipole. When is this case? It's when the right? LDF can have stronger IMF compared to dipole-dipole. When is that? When is that? Disha?
Is it when the like molecule's bigger?
Yeah, when's the molecule's bigger? So make sure to focus on the boiling point if they give you that, okay? Okay, now if it's not resonance, if it's resonance, all the bond participating in resonance, they're gonna have the same length. If it's not resonance, single bond longer than double bond longer than triple bond. Which is the strongest? Triple bond would be the strongest. Okay, so hydrogen, wait, sorry. When you have a stronger IMF, what's gonna be higher? What's gonna be higher? Madhav, you cannot be the only one. Guys, Madhav cannot be the only one who is answering.
Stronger
Isai,
bond.
I haven't heard your voice yet today. Who else? Anam, I haven't heard your voice without me having to call you. Let me see, who else is not participating? Ronica. Sophia, I don't even know you exist. Who else? I don't care if your camera is turned off. Make sure you are answering. If you want to lie down, lie down. As long as you're answering, that's good. Okay, what did I ask though? I forgot what I asked. Oh, okay. When you have a stronger IMF, what's gonna increase? Go ahead. Yeah, keep Araf.
Higher boiling and melting point
Sumit, you
and
are
lower
there.
vapor pressure.
Yeah.
Higher. I didn't know you were there. Okay, higher boiling point, higher melting point. What else? Is there anything else? Oh, yeah. Higher viscosity.
Lower vapor pressure.
Okay, good. Lower vapor pressure. That's what I want to hear. Lower vapor pressure. This is the only one that is lower with when you have a stronger IMF. Who wants to tell me what is vapor pressure? Sophia, what is vapor pressure?
Vapor pressure is the amount of vapor molecules that are running into each other and moving back and forth.
Anyone else
The
wanna
more
try?
molecules, the higher vapor pressure.
Anyone else wanna try? What is vapor pressure? Ayana?
Is vapor pressure like the pressure created by the gas molecules that evaporate in like the top of the cylinder?
The top of the cylinder? You're almost right. You're
Or like
70% right.
above
Gonna evaporate.
the water.
When it evaporate, right? The gaseous molecule, oops. The gaseous molecule is going to move around. And it's gonna what? Listen, this is important. And it's going to what? It's going to hit on the surface of the liquid. That's your keyword, surface of the liquid. And that create vapor pressure, not on top of the cylinder. Okay, not this. This is not vapor pressure. The pressure that is what? Created by the gas molecule that evaporate and fall onto the surface of the liquid. Okay, or on the surface of the liquid. Okay, do this. Okay, if which one's gonna have is X going to be more than 127 torr, less than 127 torr, equals to 127 torr. Anam.
Boston.
Less than, because
Because the boiling point is 30.
that means justification. That means it has stronger
IMF.
IMF. Okay. Okay, ideal gas law, PV and RT. Anything we have to go over that? No. But what do we have to go over though? What it deviation from ideal gas law. Also, you guys know what what R you're gonna have to use, right? Do not use the 8.314. Okay, in PV and RT, use the what? 0.0821 0.08206, and make sure if they give you the torr, convert into
You divide it by
ATM.
60.
Yeah, convert to ATM. Okay, deviation from ideal gas law. How do you make something? Okay, how do you make? Okay, this is deviation, but let's say, how do you make more ideal? How do you make something more ideal? Pressure should be, temperature should be, volume should be what?
Pressure should be low, temperature should be high, and volume should be low.
Now the volume,
high.
the volume can be two types of volume. They might ask you the volume of the container. They also might say volume of the particle gas or the size of the gas. If it's about the container, it should be high. If it's individual gas, should be low. So if you have H2 versus what? F2. Both of them what? And also no IMF. Okay? Lowest IMF. So if you have something like hydrogen bond, dipole, no, it's not going to be ideal. It's not going to be ideal. For it to be ideal, what do you need? It has to be no IMF. Of course, you cannot have no IMF, right? Everyone's going to have LDF. So lowest IMF. And comparing these two, both of these gonna have LDF, but whose LDF gonna be weaker and why?
The hydrogen gas, since it has a smaller electron cloud and is less polarizable.
Good. Make sense? Okay. That's how you're going to see something more ideal. Now, if it's a deviation, what does it mean? Just less ideal. Opposite everything what I just said.
Wait, so hydrogen gas has a lower electron cloud or a higher electron cloud? I just like didn't really hear what she said.
Lower electron cloud because why? Oh, smaller electron cloud because
Um,
the size is small.
yeah.
The size is small.
Okay.
Anyone want to ask, Sharvari? I haven't heard your voice today, Sharvari. You're planning to answer questions or no? Now, how do you know something follow ideal gas? When you do PV equals to nRT, it's going to follow this formula. How do you know something is following ideal gas? When you do PV and RT, this is its name is what ideal gas now. When you do the formula of this, you're gonna get the answer exactly. But if you do this and the answer is far away from what you're supposed to be, that means it's least ideal. Okay. So helium versus argon, which is more ideal? Madhav. Helium versus argon, which is more ideal gas?
More ideal means that has the lowest IMF. So if it has the lowest IMF, it's gonna be like weaker, right? So I think helium
Okay.
because
That's
it
okay. You're good. The small, right? Yeah. Remember, we did once have a questions like this, right? Whenever you do one question like this, you have this water. Whatever pressure you're going to collect here, make sure to minus, Anam, make sure to minus with the pressure of the water vapor. Okay, before you do PV and RT, make sure to do minus the pressure of the. Once we're done with unit 3, we're gonna take some break, okay? 5 minutes, not more than that. And then keep your Zoom meeting on though. I mean,
Wait,
like you can turn off
explain
the
that.
camera.
Can you explain that real quick? I didn't really
We
get
did
it.
this question, right, Madhav? We did this question where
Yeah.
whenever you have what? Whenever you have, what is this? Water, right? So whatever gas flowing through this, water also has its own vapor. So what on the top of this, they're all gonna accumulate on the top, but this is not just the X, it's also gonna have water, even though if they do not mention water. There's always gonna be water vapor here because you have water here. So before you do PV equals to nRT, you take the P should be P of the gas only. That means what? Whatever pressure you got, subtract with the pressure of the water, which will be given to you.
Oh, so it's
Okay?
gonna like push it down, like push the water down.
It's not gonna push, it's just before you plug it in into this formula,
Yeah.
right? You cannot just plug in the pressure that you got here. You have to do the math before you plug it in by subtracting the pressure of the water.
Okay. And they'll give you the water pressure, right?
They will.
Okay. And the total pressure? Like there?
Mm-hmm. Mm-hmm.
Okay.
Boltzmann, if you guys have helium and argon, which is what? Which is A, which is B? Someone whose voice I haven't heard today, please answer. If you feel like you haven't say anything in the last 1.5 hours, please speak now. Okay, Sharbari.
Yes. So it's
You
B
have
to B greater.
Hello?
Can you hear me?
Yeah.
I said helium would be B and argon would be A because helium has less mass, meaning it would have a greater speed.
Very good. Yeah. Also, regarding temperature, also you know, right? B would be higher temperature. And how do you guys explain? You explain that? What? With, let's say they're talking about unit 5, reaction. Okay, and they say, we're gonna go there. I'm gonna talk about that again. Don't worry. Talk about deviation. Solution and mixture. This molarity, those things you know, right? Whenever you have solution question, just make sure to do I would really like if you guys could do BCA table, but if you are more comfortable with Stoic, you can do that too. Oh. Okay, this.
I have a question.
Mm-hmm.
So like like these questions, it's like telling you to like make like a laboratory like experiment, right? So
Mm-hmm.
like I'm just like kind of confused on like questions like these. So like when I'm like practicing, I'm like getting like confused by like the laboratory questions that like require you to like make
What's
like
your question? What's your question, madam?
'cause like I just need like help with these problems. I just want to just tell you.
Okay. Okay, so we are doing this problem. Okay. Okay, so this one. What do you do? Read the question first. Think. We already did this, right? Yesterday. Was it yesterday we did one question like this? Oh, but this is what? Prepare that using, okay, this is a little bit different. This is dilution. Last time we had what? Preparation of solution. Okay, who wants to tell me?
Would this be like part of an FRQ in like the
Yep.
AP test? Okay.
Mm-hmm. Okay, fuck it. What are the
What I was
steps?
what I was
Mm-hmm.
thinking is that first you use M1 V1 is equal to M2 V2 to find
Okay.
that 1.2. So M1 would be 1.2, V1 would be unknown, V2
Okay.
would be 50 milliliters, and M2 would be 0.48. Okay.
Okay.
Now I do the calculation. It's 20. M1 is equal to, I mean, V1 is equal to 20 milliliters.
Uh-huh.
Now you need 20. Now you know you need 20 milliliters of AlNO3.
Okay.
So I think the first thing that you would do is first you would
You want to
weigh
also
out.
see, oh, yeah, you want to know your total volume first, so 50 ml, right? Okay. So, which one
Well,
are you
you
going to
would weigh
use?
volumetric flask
Okay.
to measure. But first, I think you would get the 20 milliliters of AlNO3, the 1.2
Using?
molar of it, using the electronic balance to weigh it. Then you would,
Wait. You weigh 20 ml.
yeah.
Ml is volume. You weigh
Well, like, yeah,
volume.
you have to convert it to grams first, right?
No, you have, yeah, so to get to the 20, you can use the graduated cylinder to if you have pipette, use pipette. If you have burette, use burette. Since there's none of that, you use graduated cylinder. Okay, or measuring cylinder.
Okay, so
So
the first step would be use the graduate cylinder to get 20 milliliters of 1.2 molar AlNO3. The next
okay.
step would be to weigh whatever you get from that, transfer it to an electronic balance and weigh it.
You don't have to weigh it. Why are you keep weighing it?
Oh,
Did they
yeah, you
give
can just
you
transfer.
there's no, this is useless. You don't need to use this. Okay.
Okay.
And then
Okay.
you
So then
transfer
you
the
add
20 ml.
to the volumetric flask,
Okay.
and then you add just enough water to dissolve it.
Okay.
Then you stir it, and then you add till 50
You
milliliters.
swirl, not stir.
Yeah.
Stir is different. Okay, stir, that means you have to put something and then you stir. You
Okay.
swirl. The keyword
Okay.
is swirl. You're going
Swirl.
to what? You're going to hold on this part, and then that's why the volumetric flask is like that, you know? So you can
Okay.
hold it and you can, you know, doing that. You're gonna swirl it, and then you're going to fill the remaining
Yeah, till the mark with distilled
up to
water.
total mark. But because they also say you have the dropper pipette, what can you do? You
You
can use the
can
dropper pipette to
measure
make
till
sure
one till
to make sure it's exactly on the
50
calibration
milliliters.
mark. The meniscus. Use the word meniscus. The meniscus is on the calibration mark.
Okay.
Who can repeat what we just said? Tisha?
Okay, so first you would measure 20 milliliters of the stock solution using the graduated cylinder, and then you would um like put that into the volumetric flask, and then you would add distilled water to the like halfway, and then you would swirl it to mix it, and then you would add distilled water to reach the mark, and then for like extra precision you could use the pipette to make sure the meniscus reaches the mark.
Okay, good. Perfect. You use weighing balance or electronic balance when? If you have solid. Representation, this one is just what? Just make sure what? We already talked about this, right? Just make sure whenever you do this, the size, you have to think about the size, okay? Who's bigger? MG is smaller than BR. Do not do BR become smaller than MG. Okay? Okay, chromatography. Who wants to explain? Because I'm so tired already. Who wants to explain? Let me see who. Okay, Disha. You explain well.
Okay.
Okay.
So usually
Everyone listen. I'm not gonna repeat, okay? Okay, go ahead.
the polar substance is part of the mobile phase, and then
First, no, it's not always.
not always, but
Just
you
just explain the overall, the basic concept.
you would like figure out which whether the polar or the like mobile and stationary phase, the polarity of those, and then the substance that matches the mobile phase will interact more strongly with that, so then it'll like
More
move
further.
more. Yeah, it'll move further. And so that's the one that's gonna be for since this is column, that's the one that would be like further down. But then
Okay.
for paper chromatography, it would be the one that's like higher up.
Well, basically, where it's going, right?
Yeah.
Because this is you're gonna open this faucet and then it's gonna flow down, so the movement is going down. Okay, I'm gonna repeat. Okay, first you're going to figure out what is your mobile phase. Okay, so sometimes this is not just filled with water or whatever that is liquid. There's also gonna be some solid, something there. Okay, which you don't really care. But the liquid one is mobile. That means the liquid is the one that's gonna flow, right? So the mobile one, if the mobile is polar, the one that is moving more with the mobile, so in this case, the Q, it is also going to be polar. That's it. Okay, if it's non-polar, guess what? No, Q also non-polar, because as it goes down, it's like favorite child. It also what? It also wants to go down. That's it. Okay, so for the paper, let me see, do I have the paper one? For paper, if you have what? So you start with, let's say, you start with this, okay? And then what? This is the mobile phase. So the water or whatever that is, it goes, right? It gets absorbed and then it goes up to a certain level. Let's say it goes up to here. So this is before. This is after. So it goes up to here. And this gets separated into two components. Okay, let's say it gets separated into this and this. Now, if the water is non-polar, not the water, whatever, the liquid is non-polar, that means which is non-polar, which is more polar, X or Y? Which is more polar, X or Y? Izai? Izai?
Wait, so like the liquid is non-polar?
The liquid is non-polar.
Okay, so like the one that's close.
Wait, I said Izai. Izai, if the liquid is non-polar,
Then Y is also
more?
non-polar. It's more polar.
You tell me. So the liquid is non-polar, right? The liquid went to where? Up to here?
Yeah, this. Yeah,
Right? Up to here? Who follows the liquid most?
X.
Why? Because X in love with the liquid. Because they are what? They're vibe matches.
It's non-polar.
So it's going to be non-polar.
Yeah.
Whoever followed the most. This one. Where is it? This one. The one that more bottom means what? It followed the liquid. If the liquid is polar, it's also going to be polar. If the liquid is non-polar, it's also going to be non-polar. Whoever it follow. Wait, also I want to talk about one more, okay? RF. What is RF? I don't even remember the... Anyone remember the full form of RF? Which it's... Wait.
Retention factor.
Okay, retention factor. What is it? Okay, whatever. So what? Okay, let's say it's here. Okay, let's put Y here. Okay, so what is retention factor? You want to, starting from the very beginning here. Okay, you want to, let's say this is 1. Okay, if this is 1, and then you can kind of like what? Let me use different. You can kind of separate this into 3 parts, right? But depends on how many parts you can equally separate them. But this is going to be the 1/3, 2/3, and this is going to be the 3/3, which is 1. So the whole thing is 1, right? Up to here, it's 1. For Y, it's going to be 1/3. So 1/3. Retention factor for Y is 1/3. Retention factor for X would be 2/3. Do you guys see it? Okay, so sometimes they might confuse you. They're going to give you something like this, and then they're going to give another one like this. This is the, I'm very bad with names. I don't know what there's something known. This at the end point, they do call it something.
The solvent front.
Yeah, the something front. Yeah, the solvent front, correct. And let's say this is the solvent front. Okay. And then this is they give you something here. This is the point. Okay. And they're going to keep it side by side. Wait, sorry. You're going to keep this side by side. And they ask you, what is this point? Is this X or Y? You would think, oh, it matched with Y. It must be Y. But you forgot that this is the solvent front. So you have to first what? Figure out the retention factor of this. So again, you're going to divide it into 3. So you see that, oh, the retention factor of this point is actually 2/3. So who has a retention factor of 2/3? X. So this is X.
Do you always split it into thirds?
Depends on how many evenly you can split into. Sometimes 4. I don't think that will go beyond 4.
Does it depend on how many
Yeah,
substances
the
we're
dots.
testing? Okay. Okay.
Okay. Okay, this one. What did we remember? The EMFs. You have what? What does microwave do? What does the infrared do? What does the UV or visible do? Go ahead. Yeah, microwave. Rotate the molecule like the microwave. Rotating the molecule. Infrared. IR. It's ringing. Vibrate. Ringing and vibrates. Vibrating the molecule. UV and visible. Remember, you're looking at the, Rajan, do you remember this? You're looking at the sun, right? So UV means what? You are jumping towards next level of electron shell or visible, both of this. And then this formula, energy HV, see this. Now, the one thing that you might be having a little bit of problem, if they give you kilojoules per mole, okay, and they want you to find the wavelength, what do you do? What do you guys do? Sophia, if they give you the energy to be in kilojoules per mole, they want you to find the wavelength. What do you do?
You have to use the form.
Convert what?
You have to convert it
The kilojoules per mole
into.
We did this.
Wait, were we trying to find wavelength?
We want to find wavelength, but you cannot use this number. You cannot directly use this number to find the wavelength. Why? Because you have to convert this energy into, anyone? Anish? Wait, Sumit. Actually, Sumit. Sumit.
Joules
You have to
per
convert this.
photon.
You want to convert this into joules per photon.
Yep.
How do you convert into joules per photon?
Multiply
1
by.
kilojoule on the bottom. 1000 on the top. And then because there's 1 mole on the top, 6.02 1023rd photon on the bottom.
Yeah.
Once you convert this into joules per photon, then you can go ahead, use this, find the frequency, and then use this, find the wavelength. Or if you already know about this, you can directly use this as well. Do not, Tuesday's the test. Do not use this number directly to find the frequency or wavelength. That would be wrong. So wrong. Okay? We already talked about this, right? Okay, in this one, right, they already gave you the binding energy. So you just use this energy. If they want you to find just make sure it's per electron, per photon, not per mole. You take the wavelength and then Oh, you take any energy, whatever energy, an electron from the valence shell. Which one is the valence shell? Is it this or this? Veronica, which is the valence shell? A or B?
B.
B. So you're going to use the energy of the B. Use that energy and use that. We use the formula, find the wavelength. Anyone confused how to find wavelength from energy? No, right? Beer's-Lambert law. You always use the wavelength at the highest point, whatever wavelength this is, so 625. Okay? And then you have the formula A, E, B, C. Okay, wait. Oh. Remember, there is what? There's also, let's say this is the graph. If you have point above, that means absorbance too high. What can cause absorbance too high? Yeah, Veronica.
Fingerprints on the cuvette.
Good, fingerprints. If you have points below, what can cause it? Socket, what can cause it?
If it goes too low,
Uh-huh.
it can go too low if like there's too like less of a concentration, if there's fingerprints. What we did a question yesterday and that was the
We
answer.
did the question yesterday. Was it too low? When you have
Yeah,
fingerprints, the absorbance, the recorded absorbance would be higher because something is blocking the light. So you would thought that what? The light had been absorbed, but actually it's not. Because of the fingerprint. What can cause lower of absorbance? Yeah, Veronica.
The water droplets still in the cuvette.
The water droplets. And what cause remainder of water droplets in the cuvette? Anish.
If it's not prepped with a standard solution first.
Good. If it's not prepped, do you say prepped? If it's not?
Yeah.
R. The word starting from R. If it's not? Rinsed.
Recalibrated? Oh.
Okay. If it's not rinsed with the standard solution first. If it's not, does it make sense, Sakit?
Yeah, I remember. But lower concentration is caused by it not being rinsed, correct?
Not being rinsed, not fingerprints. Fingerprint will cause
Cause it to be higher because
it would be
like it'll shield the light from going to the receptor.
Yeah,
Okay,
and you would thought that what? It being absorbed, which is not
yeah, it was
actually
being
not.
absorbed, but it was just the fingerprints. Okay, that makes sense.
And also, look at this. Again, straight line equation, y equals to mx plus b. Y is absorbance, m is your slope, x is your concentration. When you compare this with your Beer-Lambert's, A equals to EBC. So basically, your slope gonna tell you about what? Your E and B. Okay, molar absorptivity multiplied with the length of the cuvette. Length, not the height, the length. Okay, we're almost done. I think we're done. Yep. Okay, so we're gonna take. How long break do you guys need? How long break do you need? Wait, what's that speed face? Second. Wait, how long break do you guys need? Okay, Anish, just say it. You want to stop here? Is that what you're gonna say? Can we stop here, please? I think I'm good for Tuesday.
Like 10 minutes.
10 minutes? Okay, 10 minutes, okay? Whoa, Sanvi, now you want to turn on your camera.
No, I
now
didn't know
you
it
want
was
to
off. I didn't
now
know it
you
was off.
want to
I actually didn't know it was off. I was writing.
Oh, Araf too. Now he wants to turn on the camera. Whoa, that's a
Wait, my
good
camera was
timing.
always on.
He
My
had it
camera
off
was
the whole
always
time.
on.
I had it on.
No, I didn't. What?
Yes, you did.
It was on. It was off. Anyway, okay. So just we're gonna come. You guys do not have to leave the Zoom meeting. Just turn on your camera and audio. Go get dressed, eat something, hydrate, and then come back after 10 minutes. Okay, do not be late on time, please.
What
And then we're
time
gonna
is
start
the
4.
ending?
I don't know. We are just done with unit 3. 4, 5, 6, 7, 8, 9. I know, I know. I have been tutoring from morning, so I know. I'm tired too. But okay. Come back at 10, okay? back. Anyone's back. Okay. Okay, so we'll try to do 3 topics in an hour. So we'll see, okay? 4 or 5. Which topic do you guys need the most first? Well, we're just gonna go on with order, okay? I don't want to miss anything. Okay. Uh, so anything about Unit 4, anyone who wants to ask? Unit 4, concentration, molarity, what else? Net ionic equation, solubility, gas does not split, representation. Okay, do this representation. Unit 4, I'm pretty sure they usually just pick some representation question for Unit 4. So a mixture of carbon dioxide and oxygen is placed in a reaction. A reaction between those two form CO2. CO plus O2, CO2, right? And then you balance this, that means 2 of this, 2, right? Okay. And then what do? This is your initial, right? We do BCA table, but this is whole number. You cannot have fraction, okay? So you have 1, 2, 3, 4 of this. Four of this, and then oxygen, you also have 4, which is the limiting reactant, the CO. So you divide by the coefficient, right? Divided by 2, divided by 1. So this is 2, so you know it's 2. 2 times 2 minus 4, 2 times 1 minus 2, plus 2 times 2 plus 4. So you're going to have 0 of this, 2 of this, 4 of CO2. So what is it? 4 CO2 and 2 O2.
It's C.
4 C. Okay. That's it. Okay. Again, I like to do BCA table for a stoic question, but I'm pretty sure everyone's good with stoic too, right? Which I don't think this is something we have to go over. Should be good for you. We talk about okay, just because they're asking you theoretical yield, do not get confused with percent yield. Okay, theoretical yield is just basically they're asking you go calculate how much CO2 you're gonna produce. Okay, because some of you are like, oh my god, they're asking theoretical yield. What is it? Does it mean I have to find percent yield? No. It's just basically saying go calculate CO2. Okay, that's it. So just do stoic, get your grams of CO2, and then because they did give you the CO2 that actually produced. Take that, divide by whatever number you got. Okay? They ask you to find CO2. Do not put in the number they give you. Okay, not that mistake. They're not 5. Of course, they're not going to give you the answer on the table. Okay? Unit 4 is pretty simple, right? It's just, I think we can, oxidation number. Anything you guys want? Okay, I want you guys to really look at my screen. See if there anything you want to ask, okay? Oxidation number, titration. But titration, again, what? Moles of acid versus moles of base. We already talked about in acid and base.
I have a question.
Right? Mm-hmm.
So this unit is basically like you need to know like how to like write like redox reactions and like know like which element is like oxidizing or reducing
Do
and like
you have any question, Madhav? Yes.
I
What's
just
your
want to
question?
like clarify if like that's like the main thing like we're supposed to like
Yes.
no okay.
Yes. And then this.
Yeah.
How do we go ahead? We already talked about this, right? Whatever point they gave you, you always have to give extra number. Okay? So this one would be what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sharvari, do not make the silly mistake. 6.05. No. 6.5. Is that 6.5? Sharvari, is that 6.5? No silly mistake, okay? Look first. Whenever doing this, look, what is the numbers between 5 and 6? It's going down. That means what? It's getting bigger as it goes down. So you calculate from here. 1, 2, 3, 4, 5. So you have the 5.5, but you always have to give extra numbers, so 0. Okay, you guys cannot lose point on silly mistakes, okay? Now this one. 1, 2, 3, 4, 5, 6, 7. So 37.7. What's that? Maybe 9, maybe 8. Right? Make sense? Once you have the mole of one, you can find the moles of the other. Okay, so let's say they give you between calcium hydroxide, strong base, and HCl. Please, please, please do not do M1V1. For titration, do not do M1V1. There was a point in FRQ previous years. For titration, they give you guys 2 points. The first point is if you get the mole. So always go get the mole. If you get the moles of what? Once you balance this, H2O plus CaCl2, you're gonna have 2. Let's say you have the moles of what? Calcium. You figure out molarity times volume, you get the moles of calcium. Let's say 0.5. You do the stoic, find the moles of HCl. Okay? You do the stoic, find the moles of HCl. Oxidation number. Oxidation number, what's this? +1, +2, +2, +3. Oxygen -2, +1. How do you get this? You know oxygen is going to be -2. When does oxygen -1? When is oxygen -1? Ananta?
In peroxides.
Wait, Ananta not there. Okay, yeah. Okay, second.
In peroxides, when like O2 is present.
Good. Good. When you have H2O2, K2O2, something like this, okay? This is the exception. We're going to have -1 as oxidation number of oxygen. So this one you put X, you can solve for X for Mn. X plus -2 times 4 equals to -1. X minus 8 equals to -1. X equals to 8 minus 1 plus 7. Okay. And then increasing oxidation number, oxidized, decreasing oxidation number, reduced. Okay, so this is what you were talking about, right, Sakit? The points on titration?
Yes.
So what are the important points? The equivalence point. What do you know at equivalence point?
The moles of acid is equal to moles of conjugate base.
No.
Yeah.
You have to stop doing that, Sakit. I know more than you. Okay, what do we what? At equivalence point, what moles are the same? Araf.
Isn't it the moles of? I thought the same thing.
You thought moles of acid equals to moles of conjugate base?
Moles of base.
Mole of base. Mole of acid equals to moles of base, not conjugate base. Okay, at equivalence point, mole of acid equals to moles of base. Okay, so that's the most important point. So you need to figure out your equivalence point. And if you have one of the mole, you're going to be able to find the other mole. From the other moles, you can figure out what volume you need to reach that equivalence point. That is when you put this straight line curve. Okay? That's when you do that. At equivalence point, you have what? Moles of acid equals to moles of base. Now, the second important point is what? Half equivalence point. This is what you're talking about. So if the equivalence point is at what? What's the number? 14. So half would be what, Sakit?
7 milliliters.
Okay, good. Now this is where the one that you were pointing out. This is when the what?
Acid is equal to conjugate base.
Correct. You want to say what? Concentration of acid equals to concentration of conjugate base. What else is important point at this point? What's the other important point?
pH is equal to pKa.
Correct. pH equals to pKa. Now their favorite question is they're going to ask you at 10 ml, which is going to be more?
The conjugate base.
Correct. And why? How would you set up your answer though? If it's 2
Because
points.
Because it's after the half equivalence point, and after the half equivalence point, more base is being added, which will convert the acid into the conjugate base.
Okay, that's good. Yeah, that's also acceptable. But let's say if going like this, the curve. Then at this point, let's say this is again, the same point. Do you still have the same answer?
No.
So what were you gonna say? At
I'll
the
say
half
that
equivalent, at 10, sorry, at what was that? At 10 ml?
Yeah, at 10 ml, the conjugate base would be, the conjugate acid would be higher
Because?
because it's after the half equivalence point, and we're titrating a base with an acid now. So that
Okay.
means
Also,
acid is
you
equal.
guys can, good. Also, you guys can also, the other way you want to answer is that you can say, first you mention what you know about the half equivalence point. You want to say that at half equivalence point, pH equals to pKa, and concentration of conjugate acid equals to conjugate base. And then you can say what? Oh, at 10 ml, the pH is 5. That means the pH is more than the pKa. pH is more than pKa, and that means what? The base is more than the conjugate acid. Okay, that's how you're gonna say. And then, well, you can find the initial point. How do you find initial point? You do ice table. Okay, because at this initial point you haven't add any NaOH. So whatever concentration of the, whatever this is, let's say it's 0.2, they give you the Ka, or you can actually find the Ka from the half equivalence point, right? And then you can figure out what's this. If they give you the Ka and then they ask you to draw this, find the pKa, and then get your half equivalence, find the mole equivalence point, get your equivalence point at what volume, and for the initial, you do ice table. You do ice table with the initial concentration of the weak acid reacted with water. Anything else on type of chemical reaction? I don't think we have to go over this, right? Redox, it's basically just, okay, that's it, unit 4. Anything else? Anyone want to ask about unit 4? Veronica? Sophia, you there? Oh, you're still there. Okay.
I'm still there.
Okay. Any question? Okay. You guys sure, or is it just you didn't study? That's why you do not know you have question or no? You sure you have no question on unit 4? 1 to 4, no question? Okay. Okay, unit 5. Oh, wait, sorry. Unit 5. Unit 5 is, I would say unit 5 is the easiest unit. It's very, very less information you need to know, right? First, you need to know the order. Rate equals to K. Concentration, whatever the order is, M. Okay? And then what do you do? Okay. So let's say you have, also you need to know that what fine powder are gonna be, of course, gonna have a faster reaction rate, right? That is like concentration, higher concentration, higher. Okay, this is important. How would you explain increase in temperature going to make the reaction faster? How would you explain this? Who wants to explain, justify? I need to hear from someone else. Araf, wait. Sanvi, you there?
Yeah, I'm here.
Okay.
Oh, so if the temperature is greater, that means the average kinetic energy increases, which means the particles move faster and there's a higher rate of collision. And so the reaction just proceeds faster as well.
Okay, good. Also, you can also say what? There's one thing that missed. Let's say, okay, if they just ask you that, that's good. But if they draw the Maxwell graph, how would you explain? If they draw Maxwell graph, they show you a Maxwell graph and ask you why increase in temperature means reaction is faster. What would you say?
Doesn't that show that like a majority of the particles are moving at a faster rate, which means I think it has
You want to talk
the
about
activation energy.
activation energy.
And then like more particles are able to overcome the activation energy.
Yes. Okay. If they give you the Maxwell graph, that's how. Also, even if they do not give you Maxwell graph, you want to impress the reader, right? So show that you know things, not like honors chemistry level. Okay. Make sense, or do I need to repeat that point about the activation energy? Madhav, does it make sense?
Yeah, I was about to say
Okay.
that.
Okay, good. And then oh, okay. Now sometimes they're gonna give you rate of one and you need to find the rate of other thing. So for instance, look at this. They give you the rate of CO2, right? They give you the rate of CO2 and they're asking you to go find the rate of water. What do? You can do stoic. Okay, so just do what? 0.024 moles per liter second multiplied by, you want to find what? Water, right? So 3 CO2 on the bottom, 3 moles of CO2, 4 moles of H2O. You're going to get the moles. And also the product's going to form. Yeah, we haven't reached equilibrium yet. The product's going to form. The reactant going to what? Decrease in amount. Okay, so, and then you do the math, you're going to get your numbers. Okay, and water is going to form. It's going to decrease. Okay, and then how do you know? Let's say they give you a graph. How do you know what's the coefficient? You look at the what? The slope. Okay, so maybe look at this. Maybe you can look at this 10-second or 5-second. Look at how the slope changes. Okay, so for you do what? So which one is going to be the reactant? The Q. Let's say this is A. Q becomes A. So which one's having higher slope? At the same time, this 1, 2, 3, 2.5. This is 1.25. So this one is going down double compared to this, right? So there would be 2Q producing 1A. Why? Because you look at the slope. This slope is basically double than this. That means it would be 2QA. YQ in the reactant going down reactant, going up product. How do you guys do this? Anyone who does it? That's okay if someone forgot how to do this. Madhav, did you forget how to do, or do you want to answer?
Answer. So like to find like the order of NO, you basically do experiment 1 and 2, because like the concentrations of H2 at 1 and 2 are the same, right? So they cancel out.
Everyone listen, okay? I'm not gonna repeat that. Okay. Not cancel. Oh, they will cancel out.
Like,
Okay, yeah.
like
And then keep going, and then
it's gonna be like 0.03 over 0.09.
no, bigger number divided by smaller number. Bigger divided by smaller. So from here to 0.09 divided by 0.03.
Oh, like
so this
what
is 3 times.
I was
Bigger divided by smaller. No.
like trying to say
And
like
then
divide both of them like that, and then like you could divide the rates just like the same thing, like experiment 1's rate divided by experiments 2's rate, and like since like
again, 2 divided 1, not 1 divided 2. If you want to make things a lot complicated, sure, you can go ahead do that. If you want to make things simpler, bigger number, divide by smaller. So when you divide by this, it's 3 more times bigger. And then this divided by this is what? What's that? 9 times? Which
9,
order is that? Anam, which order is that? Anam.
it's gonna be
Well, not you, Madhav. Anam, which order is that?
Is the third order?
Third order, we do not have third. So how do you know the order? You do equals to 9 equals to whatever you got here, you put it there. 3, well, you can say what? This is 3 to the power of? Anam, do you understand how we got the numbers 3 and 9?
Yeah, if it's second order, could you do 3 to the power of 3?
3 to the power of x
Yeah.
equals to 9. That means 3 to the power of x equals to 3 to the power square. 9, right? So x equals to? Which order? 2. Okay, that's how you do it. Okay, so for NO, it's second order. For H2, which experiment do we choose? Now, which experiment? Inayatu, you haven't answered anything today.
Sorry, I joined late.
That's okay. Which experiment do we do to figure out the order of H2?
would it be experiment 1 and 3 because the concentration of NO is constant?
Okay. And then again, bigger number divided by smaller. Do not do the other way. So that is by what? What's the multiplication? Bigger number divided by smaller number. 0.09 divided by 0.03. 3, no? Yeah? And then this divided by this. Can someone do this, please? 220. What's that gonna give you? Oh, just 3. So which order is this? And then you do, on the concentration, just do 3 to the power of x. And then you make this equal. 3 to the power of x equals to 3. That means x must be 1. This one is first order. And then what do you do? They're gonna ask you for k. So you need to be able to go find the unit of k. Okay, you probably have not memorized the unit of k. So make sure to, for third order, so make sure to know how to find it. So rate equals to k NO square H2 to the power of 1, or not write it. If it's to the power of 0, what's gonna happen? You do not write the whole thing. Okay. And then you guys, can you guys real quick find the, no, actually, no, we do not have time for that. But anyone do not know how to find the unit of k? The unit of rate is molar per second, k, and then this one will be molar squared. This is gonna be molar. So k would be molar per second divided by molar cube. Oops, that means 1 over molar square second equals to k. This would be the, if it's per second, it is per second. Okay, this one.
The
This
rate
is,
magnitude.
what?
Magnitude.
You have the what?
The rate constant magnitude.
Oh, you already solved it? That's okay.
288.88.
That's okay. That's okay. And then for this one, if this one, okay, if this one is a straight line, how do you know? I asked you yesterday, right, to be able to plot this graph into your calculator and see which one gives you a straight line. Okay, so if this is a straight line, then which order is this? I don't know which one is straight line. I'm just making up. If this is a straight line, which order is this? Vanessa? Oh wait, Vanessa's not there. Veronica?
Second order.
Second order. 1 over is second order. If it's this one is a straight line. Which one? Veronica? 0. If this is the straight line?
First.
Okay. Whenever they say about decomposition, blah, 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 usually it's always gonna be first order, but confirm with graph. If they give you graph, confirm with graph. First order is the only one that has fill in the blank half time. First order is the only one that has fill in the blank half time. What's that? Disha?
Consistent half-life?
Consistent?
Or constant.
Yeah,
Constant.
Yeah. Constant half-life. Yeah, sorry. Half-life. And the formula that you guys do, this is only for first order. Okay, so if you see something like, oh, you can check this one, okay? Oh, is this give you a consistent half-life? What's the half of this? 100 second. Half of this, 3.1? 200 seconds. So you can figure out this is pretty much not gonna be a first order. Okay, it's not a first order. Make sense? So you don't have to even plot this graph. You know it's not first order because it does not have consistent half-life. Okay, for this one, what I'm saying? Sorry. What is catalyst N versus intermediate? What is catalyst versus intermediate? I think we're gonna make it. I think I'm gonna be able to do 3 topics in 1 hour. But yeah, what is the consistent? What is intermediate versus catalyst? Tanvi, this is the only question you like to answer every time I ask this.
I just came back. I went outside. The intermediate, it's when it shows up in the products first, and in the secondary, and then like in the consecutive step, it's in the reactants and it gets used up. And the catalyst is like it's the opposite, shows up in the reactants first and then it shows up in the products. But the catalyst also speeds up a reaction and it does not get consumed.
Okay, so first, before you are able to know which one is catalyst and intermediate, you want to be able to find your overall reaction. So this is getting canceled, right? And then this is getting canceled. Anything else? No. So you have what? 2 D2Q becomes 2 D2 plus Q2. So which one is catalyst? You find your catalyst in the reactant first. So who do you find in the reactant that we're getting canceled? A, right? So this is your catalyst. This is your intermediate. You see it as the product first. Okay. Now, what is the rate law? For each of the steps, you can just directly look at the reactant, find the rate law, right? K, A, D2Q, right? K, AQ, D2Q. Okay. Now, AQ. Okay. I want to do one type of question, the equilibrium approximation. Where is it? Okay, which of the 3 equations is least likely to represent a chemical reaction? Which one? 1, 2, 3. Ayana, you there?
Yeah, sorry, I just went to get some water, but
Which one is least likely to represent a chemical reaction that occur in single elementary steps? Ayana? Inaya too?
oh yeah.
Inaya too? Inaya too? Which one? 1, 2, 3.
Would it be the first step?
No. The first step has 2 reactant, easy to collide, done. They need to, for effective collision, what do you need? 2 things. I said effective collision, right? What are those 2 things you need for effective collision? Yeah, second.
Well, one of them would be that like high temperature.
Because, or in simpler words, you want to have? Because you have high temperature, you're gonna have high
Like
enough
kinetic energy. Oh, enough force.
energy.
Yeah.
Enough energy to overcome the activation energy. Okay, enough energy. Okay.
Okay. And correct
You want to say
orientation.
you have and correct orientation, yes.
Okay.
And correct orientation. Okay, so to get correct orientation for 2 molecules, pretty simple. They can Okay, but think about this in the third step, not third step, sorry, in third equation, you actually have 3 molecules. Okay, 3 molecules has to what? Has to collide at the correct position at the same time with enough, and so many things has to coincide together, right? So it's kind of like a little bit harder to achieve. So it will be the hardest. Wait, where is it? It's the slow and okay, let's just say, okay, what will be this? The step 2 would have to be, so you do want another NO2 on here, right? You do not want Cl, so you're gonna put Cl here. You want Cl2, so NO2Cl2. You want to have another NO2Cl there, right? Cancel, cancel. Okay, now let's say the second step is slow step. And they ask you to find the rate law. How would you do? How would you do? Veronica, are you still surviving? Yeah, okay. Okay, okay, Ayana, how do we do step by step, okay? So everyone understand too?
Okay. So first we would like write out the rate with the intermediate, and then we would see that we can't have CL. Oh, for step 2. Sorry.
Why step 2?
Because that's our slow step and rate determining step.
Okay, remember, rate determining step always gonna be the slow step. So you do rate equals to K NO2Cl times Cl. Include, even though we cancel this, you still include in your rate law. However, you know that you cannot use this. You cannot use that. Right, Veronica? You cannot use that. So what do you have to do from here, Veronica?
You have to substitute in something
You
else.
have to, using, you're gonna have to use the, you're gonna have to use the step 1. Okay, so from step 1, you can write, if this is FRQ, then you do what? Rate of forward equals to rate of reversed. Forward would be K1 or K forward. It doesn't matter what you want to. The K is not important. K reversed NO2 times Cl. Because you want to substitute the Cl, no? So solve for Cl. K divided by K, just another K. We don't care about the K. Cl over NO2. Now, this is the concentration of Cl. And what you're going to do, you're going to take this, substitute to this. Again, K multiplied with another K, just another K, doesn't matter. And then you do NO, wait, I'll just do green so you'll see. NO2Cl, but then that you substitute with this, NO2Cl over NO2. So NO2Cl, NO2Cl, multiply together, you have K, NO2Cl whole square over NO2. Who's confused? That's okay if you're confused. You're supposed to be confused with this question. Inaya, yeah? What part are you confused?
Can you
just ask me
repeat the last thing you said again
which last thing?
about the K?
You don't care about the K. If you multiply the K, you divide the K always gonna be another K because it's constant. That's not your focus on. Okay, so you basically multiply this K with this K, you get another K, doesn't matter.
Okay.
Any other question? Everyone understand how we substitute this and then go back there? And why we are doing it, because it's an intermediate. You cannot have intermediate in your rate law. Yeah. That's it. That's all unit 5. 20 more minutes, unit 6. Now, unit 6, I have seen so many of you struggle because you do not think about system versus surrounding. You do not think about system versus surrounding. Also, wait, I don't know. I think I forgot to mention in, oh, I think it's here too. Oh, activation energy. Okay, I want you guys to label this. Endo or exo? Endo or exo? Sanvi?
Endo.
Endo. Okay, so I want, okay, A, B, C, D, E, F. Look at this. I'm gonna ask each of you. We have so many levels. Okay, what is A? What is A? Anam? What is A? What's that?
That's like the like how far
Potential energy of the? Potential energy of the reactant, right? This is reactant, this is product, no? No? Reactant product. So A is the potential energy, write it down. A is the potential energy of the reactant. What is B? What is this? What is this point called as, Sakit? What's this point?
The activated complex or the transition state.
Good. The activated complex. So this is the energy. B would be, because you're starting from very down, okay, from the very bottom. So this is the energy of the activated complex. What is D? Look at this, everyone. What is D? Energy of product. What is C? Well, it has to be some from here. Okay, what is C? Inaya too? What is C?
The activation energy.
The activation energy. What is D? Araf, what is D?
D, is that the
Oh,
intermediate?
no, sorry. No, D is not. We already did D. D is not intermediate. From here to the bottom, what's that? The energy of the product, no?
Oh, yeah.
What is E? Araf again.
E is just
From,
the
what's that?
end point of the
No,
reaction.
enthalpy. E is enthalpy. Right? Now my favorite, Sakit. What is F?
It's the activation energy of the reverse reaction.
Very good. Yes. F, when you do from product to the top, that is activation energy of the reverse reaction. Okay? Anyone miss any point? You can ask now. So how do you know? Reactant, product. Araf, pay attention. Reactant, product. The difference between reactant and product would be your enthalpy or heat of reaction. From reactant to the activated complex, that is the peak, that will be activation energy. Okay? And then if you have product to the peak, that is the activation energy, but for the reverse reaction. Oh, I now remember. I also want, okay.
Wait, what is B?
Energy of the activated complex. Okay. What do you guys see? What do you guys see? Yeah, Vanessa, Veronica.
The 2 steps, the slow step and the fast step.
Which one is the slow, which is the fast?
The first one is the slow and the second one is the fast.
Yeah. Okay, because the first one has higher activation energy. The activation energy for the second is the one, for the first is this one, and the second is this one. Wait, we're done with the rate law, no? Oh, we already did this. Oh, there you go. Done. Oh, we just did. Okay. Now coming for unit 6. Okay. What about unit 6 that you guys do not understand? You always have to think about system versus surrounding. System versus surrounding. Okay, if the temperature in
Wait,
Mhm.
can you
Go
explain
ahead.
when exactly we're supposed to use this, like the system, and when exactly we're supposed to use the surrounding?
Okay. So usually the type of reaction they're gonna give you is they're gonna say, oh, we dissolve this and that into water. Okay, let's say we're talking about NaCl. We dissolve NaCl into water. Okay, when you dissolve NaCl into water, what happened? When you dissolve NaCl into water, what is your system? Your system is the reaction between the NaCl and the water. Okay, so reaction, the dissolving process. System is the reaction. So because it's the reaction, can you find the C? No, you cannot find the C. Can you find the temperature of the reaction? No, right? So what is your surrounding? Everything else surrounding it. So it's the what? The water, the calorimeter. Okay, that's your surrounding. So mostly they just ignore the calorimeter, so we just have water. But we also had done a question where if we did not ignore the calorimeter, what would happen, right? We did a question like that. Okay, so whose temperature can we figure out? We can figure out the temperature of the surrounding. Because we can figure out the temperature of the surrounding, we can check the change of the temperature. For the surrounding, you're gonna do EQ-MCAT. Because the system is a reaction, you're gonna use the enthalpy. M can either be mass or mole. Also remember, if I give you $5, you receive $5 conservation of energy. Whatever energy that system either, let's say the system, it's exothermic, the system release energy. Let's say the system release 10 kilojoules. So it's minus, right? Because it's release. The surrounding would be plus 10 kilojoules. Okay? So system reaction, you use Q M delta H. Surrounding, you're gonna use Q M cat. As long as you understand this part, it should be fine. Okay, and then if they say, oh, the temperature goes down, it becomes cooler. Is it endo or exo? Is it endo or exo, Araf? It becomes cooler. Is it endo or
Could you repeat
exo?
that?
The water become cooler. Oh, the temperature becomes colder. Is it endo or exo?
But shouldn't that be exo?
See, when they say the whose temperature can we measure?
The surroundings.
The surrounding, right? The surrounding temperature become colder, right? That means surrounding release energy, right? But who's our main character? We don't care about surrounding. Who's our main character? If surrounding release that energy must have gone to system. So the system actually what? Araf?
It absorbs the energy.
It absorbs the energy. Okay? So it's endothermic reaction. Okay? Anyone wants to ask anything about, you know what, guys, I want this to be discussion. And I can already see, I mean, like, if I'm in your place, I'll be tired too. So I need, like, you guys ask me question. What do you want to know about unit 6? You have bond enthalpy, this type of question. So this type, so for example, if you have, let me see, heat transfer equilibrium. Wait, let me see if there is a question. Okay, Disha.
Could you go over like the error analysis for calorimetry? Like what happens if like the calorimeter like absorbs like heat or whatever?
Okay. Again, system and surrounding, right? We know that whatever the energy that the system gives, gonna go, we're talking about absolute value. Of course, one gonna be positive, the other gonna be negative. It equals to the amount of the surrounding. Now the system is the reaction. What did I say? The surrounding can either be water and calorimeter. So usually we just assume it's to be 0, right? But let's say that the Q did absorb some energy, right? Did absorb some energy. Let's say the reaction release energy and Q did absorb some energy. That means didn't the reaction actually release more energy that than the one that we calculated? Don't you guys think? Because we just calculated Q of water, which is a solution, I mean, which is MCAT, right? And then we assume this is equals to this, right? But I'm so glad tomorrow is not the test. I'm basically frying all of you. At least you still have tomorrow to recover. Okay. So yeah. So because what? Because the calorimeter did absorb something, right? But we did not count that. That means the amount of that Q that we counted is actually less. Okay, so if you find delta H of the Q, it's also going to be lesser. Make sense? Okay, Saket.
I wanted to know like how to calculate delta H in kilojoules per mole of reaction given one species like delta H.
Delta, okay, so this is the question. Okay, this is the question. Let's say they give you delta, let's say the question asks you, go find delta H. I want everyone to try, do it. The question is, don't care about A, B, C, D. Just find delta H. I think this is the question, but find delta H, everyone. If you're able to do this with no help, no AI, no nothing, that means you're really good, and you can rest assured you're gonna get a 5. Now that's how I get your attention, don't I?
Huh?
Go find delta H. Ignore the ABC question, just find delta H.
Wait.
Wait, for the equation that's there.
For the equation and for the question number 6, find the delta H.
Wait, you said question number 6?
I said, sorry, number 9, I mean. I'm
Okay.
frying my own brain too. Okay, so for this question, find delta H, ignore ABC question. If you're using AI, you're just kidding yourself. So that's the type of question you're asking, right, Saket? That's what you're asking?
Yeah, it is.
Yeah? Okay. I'm gonna explain anyway. I just want you guys to warm up again. Let's see who's gonna get 5 on Tuesday.
Just to make sure, we just have to report it in kilojoules per mole, right?
Yeah. Delta H always kilojoules per mole.
Okay. Then I think I got my answer.
Okay, just send it to me in the WhatsApp group that you have.
I kind of did some of my work in the calculator though. So can I just like transfer it to?
Okay. Yeah. Think about whose Q you can find. And then from there, you can go find the Q of the other thing. And then delta H is Q over mole. That's it. Simple. Guys, go get me a 5 on Tuesday, okay? I mean, like, I feel like this batch this year is a lot better than last year. But it definitely depends on the curving. Okay, so I'm gonna show. Okay, you guys can check whether you get it right or no. And if you get it right, you can just text me, I got it right, okay? Okay, so first, whose Q? Your first question is that you want to ask whose Q can I find? And then again, think about, oh, Q system, we have to do, if it's the reaction, M delta H, for the surrounding, M cat. So do I have everything I need for the surrounding? I have initial, I have final, I have my C. Do I have the gram? Yes, I have the gram, right? So for the surrounding, you're always going to add both of the grams of the solid and solvent. So we're gonna first find the Q of the surrounding, which is MCAT, which is, what's that? 106.48 unit. I'm not gonna write the unit, you guys do it though. Okay, C is 4.18. Delta T is final minus initial.
Negative 0.79.
Okay, negative 0.79. And then what do you do? Okay, do the math. You get
Negative 351.618 joules.
negative 351.6.
618 joules.
Okay, so negative 352 joules, right?
Okay.
Also, it's very important to what? If you have to look at this, what is this? That's why I said do the unit. Because this is joules, you're going to get joules. This is Q of surrounding. So Q of system would be what? Positive 352 joules or 0.352 joules, no? 0.352 kilojoules. And then what? Delta H is what? Q over mole. The Q is 0.352 positive, divided by the moles of the solute. 1.25 divided by 53.49, that gives you 0.0234. And that gives you delta H to be
15.1 kilojoules.
15.1 kilojoules per mole reaction. Okay, delta H is per mole. Q does not have per mole. Who got it right?
I mean, like, kinda. I just put a negative first because I didn't know that, like, it has to be, like, Q system.
Okay, so you need to always think about what? System versus surrounding. Does it make sense, Saket?
I have a few questions about this. So, first of all, for the Q surroundings, the surroundings is just water. So why would you add massive water and massive NH4Cl? The surroundings is just this solution, which is just water.
Solution is just the water. What is solution? Solid plus solvent.
Yeah.
Okay, what's the other question?
And then, so you, how do I say? You like flip the sign, right? From negative 352 to positive 352 joules.
Why?
And that's, yeah, I think that's because, correct me if I'm wrong, but I think that's because when you were calculating the surroundings, that's how much like heat that the surroundings the heat that the surroundings like gave to the solution. See, heat that the surroundings gave to the system. Yeah. So then the system is absorbing that heat, which is why it's positive.
That's right. Correct.
All
Plus and minus in calorimetry, thermodynamics just show you who gives it, who gives it, and who accepts it. That's it. Does it answer all your questions, Akit?
Kind of, yeah. I feel like I'm not gonna think of this correctly on the exam, and I'm still gonna mess up.
It's okay. You can find. No, it's very simple. No. Just think about Q surrounding, Q system. Just flip it. That's it. Okay. Okay. You're smart. I know you'll be able to do this. Okay. Any other question?
So wait, quickly, just to recap, right? Q surroundings. So we first find what we can find with the surroundings. We'll always use Q is equal to MCAT, and for the Q system, we'll always use Q is equal to NH, right?
MH.
So
It might be if it's per gram, you have to use the mass.
yeah, MH or NH. So
okay.
When we're finding Q surroundings, that's how much Q surroundings has either absorbed or released. Then we flip that sign for Q system, and
you
then
divide by the moles of the actually reaction, but usually the number moles of the solute is just the number moles of reaction.
Yeah, just the number of moles of the reaction. Okay, that makes more sense.
Okay. Anyone has any other question? Veronica, did you get this right? Yeah. No. Which one? What part did you get wrong?
I didn't add
all
like,
of them.
the water and like the mass. Or I would have gotten it. I just didn't add it.
Oh, for the surrounding, the mass of the surrounding, you have to add it. Okay. Okay.
I have a question on like the type of calorimeters. Like, you know, like there's like different questions on like based on like which calorimeter it is, like a bomb calorimeter or like forgot the other type. I think it's like a water calorimeter.
I don't think that's in the syllabus anymore. So you don't have to worry too much about that.
We learned it like
Okay.
this school. That's why like I was like asking you about it.
I think it was like the previous one.
Oh, so it's
Okay.
not here on the exam right now.
Yeah.
Okay.
Yeah. Okay. Also, energy phase change. Phase change. What do you have to do whenever it has phase change question? You do what?
You have to use Q is equal to MCAT and Q is equal to NH and add those.
Draw the graph first. Draw the graph first, guys.
Okay.
Draw the graph first. Know where you are at right now. Okay. Oh my God, you got all of you got this one wrong, like right last time. All of you got this one wrong. Okay, so see this one. It wants to what? Go from 20. So first, once you draw this, right? Well, actually, you don't have to draw the whole thing. You can draw what you have. So right now, you want to first label your melting point. So this is melting point, which is 31.6. Where do you start? 20. So go from 20 to 31.6. And then you want to what? Melt completely. So completely melt it. Let's say after melted completely, they say they want to go up to 40 degrees Celsius. Do another one up to 40 degrees Celsius. In this case, you have to do 3 calculation before you add them together. Okay, so this one would have been QMCAT, this QM delta H, this another QMCAT, but they should have been giving the specific heat capacity. So this one is for the solid, and they would have given you another one for the liquid.
Wait, another one for gas as well, right? If you're about to like vaporize it.
Yeah.
Okay.
Okay. Make sense? We did a question like this one yesterday. Any question on this?
Yeah, I'm almost done solving it. Can I just do this for a second?
Yeah, sure. I don't have the answer though. But
that's fine.
yeah.
H20.
Just make sure. See, this one is in joules. This one is in kilojoules.
Yeah.
So convert either one of them to get the unit. Okay, to get the same unit before you add them together. Is there anyone who needs me to show exactly how to do this? Just raise your hand. That's fine. I can show you. No? Okay. It's basically the same.
Wait.
Mm-hmm.
Can you show me how to do it?
Okay. So first we do QMCAT. Tell me the numbers, okay? So the mass is, the C is per gram, so I'm just gonna do the per gram. What's the mass? 575 gram. The C, 2.76 joules per gram Celsius times delta T goes from, we just do from this, okay? We do this.
Yeah.
So 11.6. That gives you
that
what?
is 18.4.
18.4 joules. Next, you
Joules,
do
yeah.
Q M delta H, but your M, because your delta H is per mole, you have to make sure to convert your to mole. So
So N
you do.
is
Find the molar mass, and then you'd like.
They did not give you the molar mass. Oh, you have to find the molar mass. Go ahead, find it.
It's 172.27.
72.7. So I directly put it here, okay, on the M, and then you can solve it first before you put it into those. And multiply with delta H, which is 28.3 kilojoules.
72.79, right?
So 8. Okay. And then what do you get? 0.575 divided by 172.8 times 28.3.
I got 0.0944.
0.094. 3 sec fix.
Yeah.
4 kilojoules. Now this is kilojoules, this is joules. Convert this into joules. So 1, 2, 3, 94.4 joules. Add this and this together.
Oh yeah, I forgot about it. You have to add.
Okay, you have to add.
Okay.
And then that's it.
Wait, so
Okay.
You can also convert 18.4 to kilojoules and then add that to kilojoules.
It's just, but don't you see the numbers already weird enough?
Yeah, I know.
Yeah,
I'm just saying, like,
right? So yeah, you can, yeah. Madhav, yeah. What is it, Madhav?
So for like the final answer, you you just basically like add up all the Q's, like the Q's from like the Q M delta H and like the vapor like all of the other ones, right?
Correct. Correct. Um, bond enthalpy, you guys know, right? What is bond enthalpy formula? The everything on the reactant minus everything on the product. So make sure.
Wait, is
again,
it product minus reactant or reactant minus product?
For bond, reactant minus product.
Okay.
For bond, reactant minus product. Okay, everyone who's already sleeping, some of you, I don't know, Ayana probably sleeping. Isai, definitely
No, I'm here.
sleeping. Prajin also definitely sleeping.
I'm here.
No, I'm here.
No, Isaiah, I'm pretty sure you're sleeping though. I'm just kidding. Okay, so first, what do? Draw the Lewis structure. If they say 3, draw 3 of them. Because our mind, do not overestimate. Okay, overconfidence is very bad. Underconfidence also bad. But I would definitely, if I have to choose one, I would go for underconfidence compared to overconfidence. Okay, so do not be that student who is overconfident that would know without drawing 3 of them. Just draw it. Okay, just draw it. And then N2. Okay, now that you draw it, you know that, okay, oh, actually they already gave you, oh, nitrogen-hydrogen bond. Okay, now what do you, oh, I missed my N. Okay, now what do you do? What do you do? So you know that hydrogen-hydrogen bond, each of this is 436, right? So you have what? 436 multiplied with how many hydrogen-hydrogen bond you have? 1, 2, 3. Plus nitrogen-nitrogen bond is 940 minus product. In product, what do you have? 1, 2, 3, 4, 5, 6. You have 6 of, let's say this is X, equals to your delta H negative 92. Do I have to do the Veronica? It's outside. It's outside, very interesting. Do you want to go outside now? I know. Well, just one more day, guys. Just one more day. That's it. Okay, and then you solve for X.
I got 403.5, and that's not any of the answer choices.
Let's check.
Oh, I did 463 times 3, not 436 times 3.
Okay. Make sense, everyone? Yeah, Inaya too?
So you just like get like 2,240 8 like kilojoules per mole for like the reactant side, and then like you just
Minus 6X equals to negative 92.
yeah, so you just like shift like that to
Yeah,
the
algebra, Madef, algebra. Okay, Inaya too, what are you going to say? You have to go? That's what you want to say?
No, I was gonna ask if this is like the only formula where it's like backwards, where it's like the reactants minus the products.
Yes.
Okay.
Yes. Other than that, products minus reactant. When it's about bond, reactant minus product, okay?
right, the answer
Same
is
goes.
right
I don't know. Probably, yeah.
because like I like added it and I divided by 6 and I got 3.
Yes. Yes. Okay. Oh, Hess's law. Hess's law. Oh no, we haven't gotten to equilibrium. Hess's law versus equilibrium constant manipulation. Hess's law. Okay, so we're gonna do the Hess's law first. So if you want to see, yes, Sanvi, you wanna answer?
Yeah, I was going to answer.
Okay, that's okay. So first, Okay, if anyone's still shaky on the Hess's law, please pay attention. Okay? You're gonna have your goal reaction. Or whoever already know, just do it. Do it. See if you get your answer. Why would you have to listen to me? Blabbering things you already know. Do it. A good practice, right? So you want to find N2O5, right? So where can you find N2O5? This way. But you have to ask yourself two things, right? Is it the correct position, correct number? You say, oh, number's correct. It's 1, 1. Position's not correct, so I have to flip the first one. So let's flip the first one. N2O5 becomes N2 plus 5 over 2O2. Delta H is negative 11.3. Okay, now I'm good with my N2O5. My water, where do I find my water? Okay, I find it here. And just make sure you do not have any other place where you find water. If yes, skip it. Because I only find water in one place. Again, I ask myself, is it the correct number, correct position? Do not feel shy to ask yourself that. Okay, do not feel shy to ask yourself. Do ask yourself, is it correct number, correct position? Neither. I have to flip and I have to. Also, I cannot multiply. I can do what? Oh, yeah, you can multiply by half, right? Or you can divide by 2. Same thing. So this one, you're going to flip it, which gonna give you 2. When you flip, okay, 2H2O, I'm just gonna flip it first, okay? 2H2 plus O2. And when I flip, my delta H now will become positive. But I also want to make it 1, right? So I have to multiply by half. So this is going to be 1. This is also going to be 1. This is going to be half. And this one, I also have to multiply by half because I multiply the reaction by half. Next, where can I find 2 and HNO3? Again, ask yourself, is it correct position, correct number? It is for both of them. Oh, wait, sorry. It is correct position, not correct number, so I have to multiply it by 2. So everything needs to be multiplied by 2. So H2 plus N2 plus 3O2 becomes 2H NO3. And that one you have to multiply it by 2. Negative 206.6 times 2. So what's that? Now, whatever you can cancel, start canceling. So this is 6 over 2, right? Which is 3O2. So this whole thing can cancel with the O2. What else can cancel? H2 cancel out, right? So there you, wait, N2 cancel out. There you go, you have N2O5 plus water becomes 2HNO3, and now you add everything, whatever answer you get. Any question? Has this still make sense? Veronica, practice on this.
I get negative 130.
Did you get negative 139? I don't know. Okay,
Yeah, I got
maybe.
that as well.
Okay, Veronica, did you get that?
Yeah.
They subtract
Okay.
like 6 figs here. Because I got negative 138.7 from like the
It's a
past.
multiple choice. Again, 3 6 fix for FRQ, right, Madhav? So keep your, everyone, keep your answer 3 6 fix. Do not go and track your 6 fix. Just keep it 3. Okay, has a slow done. Oh, we did this. Oh, we're done. Oh, okay. Do you guys need break or do you want me to continue? Break?
Continue. No, we have to throw.
Okay, okay. Who voted to take break? Raise your hand. Oh, only 3? Only 3? Oh, Veronica. Okay.
I guess we should finish it all and then we could take a break.
Forever.
I think. Like,
well, after Tuesday, it's forever for you guys. You can take break forever. Okay. What? Okay. For next equilibrium. Okay. Oops. Okay. Equilibrium. What is equilibrium? Two things. Concentration should be the same, and then the rate of forward equals to rate of reversed. Inaya, you just join Inaya too. You join late, and you're the most tired one. Okay, and then okay, what about equilibrium? Okay, maybe you guys ask me question. You have done a lot of questions, right? What about equilibrium you need to know?
it's the products over the reactants for the
I asked, what do you need to know?
Oh,
What question? Okay, Veronica, what question you have on equilibrium? You know everything.
Yeah.
Okay, that's good. That's the spirit. Anyone else? Any question?
Can you like give a small breakdown on when we have to know if we have to compare the K value with the Q, or when we have to use like an ICE table and stuff like that?
Okay. Okay, whenever you compare, okay. Whenever they give you initial concentration, initial pressure, whatever, okay? Whenever they give you initial concentration or pressure, what do? You always, well, unless one of them is zero. So let's say you have A plus B becomes 2C, right? And they give you initial concentration of C, because equilibrium can start either way. You can start with C and equilibrium will reach. You can start with the reactant, equilibrium will reach. Okay? So, let's say they give you C72. Well, what's that now? 7.2. Or maybe 0.72 molar. Okay? Now, and these are zero. And they're not going to say zero. They're just going to say you're started with this is this much of C. That's it. That means A and B is zero. Now, well, yes, you can go find your Q. But whenever it's zero, you already know it's going to go to the left, no? You already know it's going to go to the left, because is it even possible to go make something that you have no reactant? If you have no reactant, you're going to go proceed to the right. The only way is to the left. Right?
Yeah.
So the only way is to the left. Okay, this is like, or if you still want to do the Q, you can. So Q equals to product over reactant, C squared over A and B. Because your A and B is zero, dividing by zero gonna give you what? Let's see, Anish, dividing by zero gonna give you what?
Undefined.
Undefined or infinity. That means too large number. Okay, that means Q is very large. So Q would be higher than K, or K would be smaller than Q. The reaction will go to the left. Okay, so it's a good practice for you all to always do the Q. And you absolutely need Q whenever you have all the amounts. Let's say you have 0.2.37, and this is maybe 0.015. And then, of course, they need to be able to provide you with K. Okay, and then you compare with K. If Q, and also, right, if you do not know how to remember this, just write K versus Q. If it's going to if K is larger, look at the direction. It's going to the right. K smaller, look at the direction. It's going to the left. Okay, write the K, write the Q, see which is larger. Okay? Make sense? Do use Q. Also, we did a practice question, right, on the how the pressure was affected, right? When the volume is double. In that case, you do have to
use Q and compare.
Yes, you have to do the Q. Okay? Make sense? Any other question, please? Equilibrium. I don't want to go over everything. Product over reactant. Plug it in. Everyone knows that, right? What point equilibrium reach? What point equilibrium reached? Inaya too?
I was
What's
gonna
that?
ask if you could go over KSP.
Yes. Okay, at this. What equilibrium, what is the time equilibrium reached?
Like after, like from like T5 and onwards.
Because?
Because
Well, at what time it reached, I did not ask when is the equilibrium? What's the duration of equilibrium? When it's reached, not onwards. Word. Okay,
after,
wording's important. At
like,
T5.
yeah,
Okay,
like,
at T5 it reached. Not onwards, not beyond. Okay? Okay. Yes, KSP. We're gonna do it. Just looking at anything that you need to know. When K is when K is larger than 1, what does it mean? When K is lower than 1, what does it mean? Okay, Sanvi.
So when K is greater than 1, that means there's more product than reactant and it's product favored. And if the K is big enough, it should go to completion. And if K is less than 1, that means that it's reactant favored and that there is more reactant than products.
Okay. Equilibrium constant. Okay, what happened? Okay, what happened here? Go ahead, do it. We what? We flip the reaction, we multiply the reaction by 2. So what happened to the K? What do you do when you flip the reaction, what happened to the K? Anam? When you flip the reaction, what happened to the K?
You do 1 over the K. So like it's like
Good. And then when you multiply by 2, it will become power. Right? Then 2 power 2. I think it's this. Not sure. Okay.
yeah, I got that.
Yeah.
I got the same values.
Wait, it was 8, right?
I think so, yeah.
Okay.
Okay, representation. Do this. Do this, everyone. What's the plan? Sharbari, you're still listening. I can't see you, Sharbari. Okay.
The
What's
K,
the... I'm not asking you, Madhav. Sharbari. What's the plan here?
Oh,
Hello?
I'm not really sure.
Let me see. Rajin, what's the plan here?
So we have the reaction there.
Why you sound like you're sick already, Rajin? You were fine like I think an hour ago. Oh, were you sleeping?
No, I wasn't sleepy.
Okay, so go ahead. What do you do?
Um, I understand the concept, but I don't know what to do.
Well, this is a very simple question. You just find K product over reactant for each A, B, C, D, and see which one match 4.5. That's it. That's it. Easy peasy. No?
No,
Just
I
do
still don't
product.
understand.
Okay, that's okay. So do you okay for A? Let's do A. Okay, that's not the answer. I'm just like for A, what do you do? First, you have to set up the equation. Kp equals to P of D2 times P of G2 whole square over P of DG2. No? Whole square, yeah?
Yeah,
Yeah,
now I
Prajin?
understand.
Now you understand. And then you do what? Okay, you check how many D2 I have. The black one. So 1, 2. 2 times how many G2 I have? 1, 2. So 2 squared over how many DG2 I have? 1, 2, 3. So 3 squared, check. For each of them, check, see who match 4.5. That's it. Simple question. Okay? Okay, Lee Chatelier. Well, we already talked about Lee Chatelier, right? You're going to explain. Listen, if you want to get full point on justification, don't say, oh, it's going to go to the left because there is what? More moles. It's going to go to the right because there is less mole. Oh, there is more of that. It's trying to balance. That's honors chem. Okay, or maybe regular chem. You're in AP chem, so you want to justify based on Q. First, figure out your Q. Compare Q and K, so K versus Q. And then you say, oh, because there is more K compared to Q, it's going to go to the right. Make sense? That's it. Okay? So when you say what? Additional of D2, what happened if you add D2? You would say, what? Q equals to dx whole squared. Let's say it's over D2 times x2, right? So when you add D2, you add this, the Q will decrease, no? That means K will be more than Q. So which direction is going to go? To the right. Who wants to do the justification? Who wants to repeat what I just said? Let's see. Who did not listen to me? Okay, Naya too. Oh, no. Okay. How do you justify when D2 increase, where does it go? What happened to dx? That's the question. When D2 increase, what happened to the amount of dx? And justify 2 points.
Wait, do you want me to like actually solve it or just justify?
Just justify.
Okay. So first you
Well,
would
basically just repeat what I just said before. Because I
okay.
did justify. Okay.
Okay.
Based on Q.
Okay. So but you would find the Q value of the reaction
You don't
because
have to find the Q value. They did not give you the D,
oh,
how much
okay.
it increased by. What do you say? You're going to draw or write down the equation for the Q. Okay. And then you would say increase. I'm going to ask someone else to repeat. Okay.
But aren't they the same like for the Q and the K? Because I
No,
thought
they're
like
not the same. Well, they are
well,
the
I
same
mean I
in
know it's
terms
like the
of,
initial, but like because you have to compare them.
that's the thing. Previously, this is what? At equilibrium, but then you add D2, that means you disturb the equilibrium. Now it's not equilibrium anymore. You increase the D2. When you increase the D2, what happened to your Q?
Wait,
You
what?
divide by a when you divide by a bigger number, what happened to your Q?
It increased.
You divide by a bigger number. Bigger number.
It would decrease. Sorry, I
So
thought you
Q
said a
would,
bit bigger.
yeah, when you divide by a bigger number, it
It
will
would decrease.
it would decrease, right? So which one is going to be more? K.
Okay.
K would be more than Q. So when K more than Q, which direction's gonna go?
It would shift towards the products.
And the dx will increase. That's your justification, full points. If you want to get your full points, see, you cannot miss the question you already know. Okay, that's how you're gonna answer. Any other question on equilibrium? I know KSP. Lee Shetlier, any question on that?
Can you explain KSP?
Okay, everyone has, whenever you see any KSP, whenever you see any question on KSP, let's say that's the question, write the expression. What do you guys do? Do it, guys. Do that. Everyone do it.
Wait, we're just supposed to find the KSP equation, right?
Now everything.
Oh, everything? Okay.
You know what? Right now, I'm gonna stop talking and I'm gonna give you guys things to do, work. I'm already tired. Unless you guys ask me to explain something. Okay, what is it, Inaya?
Do you have like an estimated time will be over?
Estimated time for oh, I think maybe another hour because we only have 2 more units, 8 and 9. Well, 8 is pretty big, but I hope I already trained you guys well, especially those, yeah, were with me from the unit 8. Yeah, another hour and that's it. You're done, Sakit?
Yeah, I just had a question. I think we need volume for this.
No,
I don't know how to do it then.
because you can convert the gram per liter to mole per liter. No?
Oh, yeah, obviously.
See, because you guys doing this, you don't have to do self-study, right? At least you don't have to do self-study. Or do you still have to do? Are you gonna do self-studying, Sanvi? Yeah. Okay. Because most of what I said just like goes in, goes out, right? That's why.
No, I just wanna like practice more.
That's good. That's good.
Excuse me. So for example, if we're doing like PV is equal to nRT, this is something unrelated. But if we're doing PV is equal to nRT for an FRQ, do we have to write? Can we write like if we're trying to find P, let's say, then do we have to write like n moles times rate constant with the units times temperature in Kelvin, or can we just write the numbers?
You do want to write the units.
Units.
Okay.
All right.
You do want to write the units, even though the points, the guideline do not need you to write the units because usually it's just 1 point. So as long as your final answer has the correct unit, you should be fine. But if you're someone who does not struggle with limited time, like you just write the unit then, okay?
All right.
Why? Yeah. Everyone got it? So whenever they ask you KSP, whoever KSP they ask you, they give you, you always what? Write the reaction. What type of reaction do we write, Araf? For the KSP they give you?
What type of reaction?
Yeah. I said whenever KSP given or asked, you write a reaction. What reaction?
Well, I know it splits into PB2 plus and BR minus squared.
Well, basically, whenever you are given with KSP, you see KSP, you write a reaction that split the ions. Okay, not molecules, ions. So PB2 plus 2 Br minus. Okay, whenever, let's say they give you 2 KSPs for 2 molecules, for 2 compound, write for both of them. Always. Even though they did not ask you. Even though it's unrelated. Okay, just write it down. It's easier for you to think. So from this, KSP expression would be, this is solid, right? PB2 plus times Br minus square. This is solid. Solid. Always start with solid, so no. Now, how do you calculate the molarity? You just basically convert this into moles per liter, right? So 4.34 gram per liter. What? 1 mole is what?
367.008 grams per mole.
Gram per mole. That's it. And you get your molarity, which is 0.12.
0.12.
What did I say, Madhav? How many times do I have to say? How many sigfigs?
0.01.
3 sigfig. The zeros on in the front are not significant.
Mm-hmm.
So 3 significant figures there.
Okay.
118. Okay, mole per liter or molarity. Okay, now this is your what? This is the solubility. So if you do the ice table, Again, those who are keep asking me, please explain KSP, please explain KSP. Inayatu, talking about you, eyes on the screen. Now what do? You do I stable. 0 plus 0 plus x, sorry, 0, 0 plus x plus what here, Inayatu?
Wait,
Plus here.
2x.
You can do not zone out now, okay? You all can zone out after Tuesday, not now. Okay, so basically this is what? This is the solubility. So basically, oh, you can also, instead of x, you can put s, okay? Because we're talking about solubility. So this is basically what? Your s. And then you can go in, plug this in into here. And then plug it in into this formula. So this is going to be 0 0.0118. This is going to be 0 0.0. What's that? 236.
Yeah.
And then you do KSP equals 2. Again, look at this. Look at that. Your PB2 plus is 0 0.0118 times 0 0.0236 whole square. Now, in here, you do not plug in your unit. Okay, do not plug in your unit. Because KSP do not have unit in whatever answer you get, which is, what's that? 6.62 10 negative 6. Make sense? So for KSP, for those who keep asking me, can you tell me about KSP? KSP means what? First step, do the reaction. Once you do the reaction, you're going to get what? You're going to make the I stable. Instead of the X, you have the S, which is your solubility. Sometimes they give you per gram per liter. You can always go, even though without them have to ask you convert it, go convert it. Because in I stable, it either can be molarity or pressure. Okay, and then you plug it in into each of this, and then you find your KSP. Make sure, do not forget to multiply this by 2. Do not forget to multiply this by 2. Yes, mother.
Oh, when
You
I
get it?
did the KSP, I got 6.57 times 10 to the power negative 6, so
That's okay. Doesn't matter. Make sense? Yeah? Okay. What other thing you guys want to ask me in this? Okay, we're gonna do acid and base. What about acid and base? We already talked about the titration graph. What is buffer? Right? I don't have to go over
a week.
pH, pKa, right? pOH. The formulas you all of you already know.
Wait, Miss Farida,
Mm-hmm.
could we take a short break?
Yeah, and I'm sorry. Yeah, we can. Okay, we're just gonna do to you guys can take 15 minutes. That's good for everyone.
Okay, thank you.
Yeah? Okay. Just take a nap, okay? I'm back. Okay, you guys can do number 8. Go ahead. This last 2 units, we're just gonna do questions, okay? I feel like even though if I speak and talk and talk and talk, it's not, it's just, so let's just do questions. Do the question. Ice table. Find the X, find the OH minus, find P, right? Oh, yeah. And then do the KB. But using the pH, you can find the OH minus, but right? Using the pH, you can find POH, find the OH minus, plug it into the ice table, get your X and initial product of a reactant, get your KB. You're done, Sakit?
Yeah.
Okay. Rajin, you're doing? Isai, are you doing?
Yeah.
Send me the work, okay? Everyone who's whatever you're doing, once you're done, send me the work in your each own WhatsApp group. Take a picture, send your work. Anyone did not get C? No? Madhav, you did not get C?
I was kind of confused with this problem. I just need your guidance for this, and then I could like probably like understand it.
Okay. So you do I stable. You have your initial 0.1. Don't care. 0, 0, minus x, plus x, plus x, 0.10 minus x, x, x. Now what do you know? You know your pH, 9.11. pOH will be what then? 14 minus 9.11, which gives you
14 minus 9.11 is gonna be
5.89. Wait, please confirm. 4.89. Okay, now that's your pOH. From pOH, you can find your OH minus concentration by doing 10 to the power of negative 4.89. That gives you what?
I got 1.29 times
1.29 times 10 to
What?
the
5.29?
1.29 times 10 to
1.29 times 10?
the power negative.
Negative 5. Yeah. Now you have your OH minus, which is actually just your X. 1.3, 1.29 times negative 5, 1.29 times negative 5. Then what do you do, guys? This is just going to be 1.1 because that's just super small number. You do x squared over 0.1. X squared over 0.1, right? Because that's your KB. So KB is this times this over this. So x squared over 0.1. And then this is your x. Okay?
So the
Make sense?
concentration of OH minus was the X that we plugged into the final thing?
Yeah, that's your x. Right? Yeah. Number 10.
Excuse me. I was doing number 9, and I didn't like. I was just doing it while everyone was doing number 8, and I didn't really know how to do it. Can you do that after?
Number 9.
Yes.
Which one do you not know to do?
How do we
How to-
find HA using these concentrations?
Well, you have the Ka value now. Just the same way, you do I stable again. You do I stable again. Well, HA is basically just that thingy.
Yep. It's this, yes. So
Now you have the pH, you know, the H3O plus, right? Oh, actually, they already help you. That means this is your X, right? So X squared over initial equals to this. So you can find your initial. Okay. Okay. Number 10, go ahead. Write on a paper. I need everyone to show their work. Send it to me once you're done. Again, ice stable. And C as well, okay? Everybody send your work. Prajin, Prajin, are you there?
Yeah.
Send your work. Isai, send your work. Sumit, send your work. Okay. Oh, you did.
That was for the last one.
Oh, yeah.
Wait, do we have to do all of them or just A?
ABC.
All right.
ஹலோ நான் ரெக்கார்ட் பண்ணிருக்கேன் ஓகே எனக்கு டேட்டா எனக்கு இதுவே இல்லை ஃபர்ஸ்ட் ஆஃப் ஆல் ஸ்டோரேஜே இல்லை
You're done, Anish?
No. I'm on part B.
C is 2 point. C is 2 point. Okay, I need the C to be really good. I already shown you guys how to do it.
Wait, just to clarify, the percent ionization is like the amount.
X over HA. X over HA times 100%.
Okay. Can I?
Whoever did not get the answer, let me know, okay? 1.6. If you did not get 1.6, let me know. See, I'm gonna ask someone to explain their answer, to read their answer. 2 points, okay, see? This is 2.7%. And I really need you guys to do I stable. Okay, let me see whoever already sent me just now. Good, Sharvari. Wait, but your pH is not good. Wait, what happened here? Whatever you got is not the pH, Sharvari. That's the concentrate. That's your X. right? And your X is your H3O plus. To get pH, you do negative log of that. Okay? Good job, Madhav. Disha, do it the way I did. First, you have to do the Q. Do the Q. Q equals to what? And then when you add the when you add the what? When you add the volume, you basically double the volume, right? When you double the volume, what happened to the concentration? Become half. Do half, half, half. Do it that way. Okay. Well, good job, Sumit. So, for this, what do you do? Product over reactant. Look at this. Look at this. How to explain? You want those 2 points? Look at this. The Q, because you increase the volume, you basically double the volume. It is now half. The concentration is now halved. This cancel out because one of them cancel out. You have what? Q would be half of K. That means who's more? K. K more than Q. That means what? The HF will? It will go to the right, HF will decrease. If you did this, 1 point. And then you'll have to explain like what? Because K is what? Larger than Q. It's going to the reaction going to the right, reducing the amount of HF.
Miss Farida, I have to go because I have to take a mock test for another AP.
Okay.
I have to go at like 3:30.
Oh, right now?
Yeah.
Okay. Okay, this one. Do this one. Remember those 4 things that I gave you guys? Always go back to that, okay? And then 1 net ionic. And who breaks down? Strong acid and strong base. Weak acid, weak base does not break down. Then you do BCA table. For B, to do B and C, you basically just need BCA table. If you have your BCA table, because it's acid plus base, right? You will be able to do B and C. Naya's just getting princess treatment from her sister. So, strong acid, we just take H plus. Strong base, we just take OH minus. Becomes water, liquid. Right, AQ, AQ. So here I'm just gonna do the BCA table. Why do I give single arrow? Because strong. Find the mole. What's the mole? 0.080. Right? Multiply those two. OH would be multiply this 3, 0.090. Why are we finding the mole? Because acid and base, we do BCA table. We don't care about this. So the limiting is 0.080 minus 0.080. This is 0, this is 0.010. This is the what? The mole of OH, right? So to find the pH, pH is what? Negative log of H plus, right? Well, you can first what? You can first find POH by doing negative log of OH minus, right? And it's concentration, not moles. So if you made moles there, that's going to be wrong. They did give you the volume, so make sure to go take the mole of the OH, divide by the volume, 0.5. That gives you what?
0.02.
0.02, and then plug it in here. Negative log of 0.02, that will give you the pOH, and for pH you do what? Or this is what, 1.7, and then pH 14 minus 1.7. Okay, make sense? BCA table. Okay, this one. Well, I feel like I want to go over everything, but let's not. Let's not fall into this trap. Okay. Number 5. Think, do, solve. Everyone needs to have their own answer. An explanation, why do you think that's the correct answer? By looking at the key K value. K value is very important in this case. Ayana?
I thought the answer was B, since the K value was really small, and so there was like more reactants, or it tells us there's more reactants, so HCN would be a stronger acid. And since HCN is a stronger acid, its base is kind of weaker. So then it would be weaker than F
Well,
minus.
wait, it's going to the left. It's going to the left, right?
Oh,
It's
okay.
it's going to the
So then it would.
left.
Mm-hmm.
It's going to the left. So who's actually a stronger acid?
HF.
HF is a stronger acid. Look at this. You look at the K value, guys. K value less than 1, going to the left. Going to the left means this is your reactant. That means HF is going to be able to be a stronger acid. And who's the stronger base? Cn minus. That's it. Okay, HF is the stronger base, is a stronger acid. Cn minus is the stronger base. If it's positive, blah, 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 then it will go to the right. These two are going to be the stronger acid and base.
Okay.
Okay. Wait. Sit. 7. A simple question. Araf.
I'm still thinking.
Sanvi,
Yeah.
7.
Yeah, I'm working on it.
Almost done, guys. We're almost done. Sumit,
Can I say the answer?
yeah.
Is it B because at the equivalence point, all the NH3 has been consumed by HNO3, and it's entirely into NH4 plus,
And what is NH4 plus?
the conjugate acid of
Yes.
yeah.
Therefore, the pH is lower than 7. Okay, 9. Can you guys see it?
I can't see B.
Use the information in the graph to determine the approximation value of pKa.
Okay, thanks.
What's the pKa? Do it, everyone, do it. This is the unit that's you're gonna get the most tomorrow, most probably. This is the unit you're gonna, oh sorry, on Tuesday.
Isn't it
This is the unit 8, acid and base.
like isn't unit 3 having like more problems though? Because like
Well,
in the
unit 3, well, they do say that. They do not, the thing is, every year, if you go back to the question, it's always the unit 8. Always the unit 8. Because unit 3 is like, you can just keep unit 3 in every question. Oh, find the IMF, blah, 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 blah. But this is going to be the kind of like, oh, the long questions start from here. Acid and this and that.
Okay.
And if you do well on unit 8, you'll feel good. Because you guys can handle unit 3 for sure, right? Unit 8 is the one that's going to either make you or break you. Take a screenshot of this on the top of this, please. I'll just like scroll. Take a screenshot of this, a picture. Screenshot or picture. So then I can scroll down to the questions. Got it? These are the questions.
Could you go up again real quick? Sorry.
Okay.
Okay, thank you.
Yes, Sumit?
We can use BCA table for D, right?
No, that's a half equivalence point. No? No? What do we know at half equivalence point? Sumit? Sumit?
Yeah.
What do we know at half equivalence point? 10 ml, 20 ml is the equivalence point. 10 is the half. What do we know at half equivalence point? That the concentration of what?
Acid to base.
Well, wait, let him speak. What, Sumit?
The concentration of acid is equal to base.
Is it? That was equivalence point, right? Moles of acid equals to moles of base. What do we know at half equivalence point? That the concentration of acid equals to conjugate base.
Oh, yeah.
Right? We know that. So you have the amount of acid, weak acid. Guess, and that is the point that they gave you. That is the point of what? The half equivalence point. So guess how many more do you have to draw of the conjugate base? Sumit?
Like 2 times more?
Why would it be 2 times? We just talked about this. They are supposed to be the same at half equivalence point. It's supposed to be the same at half equivalence point. Well, wait, that's okay. What's supposed to be the same at half equivalence point? Okay, recap. At equivalence point, what's supposed to be the same? Sumit. At equivalence point, good. At half equivalence point, the volume half of it, what should be the same?
Concentration of acid and conjugate base.
Okay, what is this? What is that?
Acid.
Okay. And what do they want you to draw?
Conjugate base.
At what point?
Half equivalence point.
So what do you think they should be? What should be the conjugate base?
Like we have to draw 4 of them.
Because?
There's 4 acids, so and at half equivalence point, concentration of acid is equal to conjugate base.
Correct. Make sense, everyone?
Yeah.
It's okay. Anyone has any question? No? Okay, sorry, one more. E. Basically, what did you change? You changed the volume, right? The HA concentration was, volume in trial 1 was 15 ml. Now you make it 30 ml. Draw it. How would it look like? When you draw it, what's going to change? Is the pK going to change? No. What's going to change? Sharvari did ask me this question, right, yesterday? How do we know they're exactly there? I said, find one of the mole and find the volume at which you will require it to be. What is the concentration of HC3, that thingy? So because you're basically what? adding more. You basically double the concentration of the acid. Now, wait, did I say concentration? I mean mole. Basically, you double the mole of the acid. Now, we know that at half equivalence point, you will need same amount of the acid and the base, right? If you double the acid, guess how much of KOH you're gonna need? Anish?
Double the amount of that.
Which means of course, to reach equivalence point. That means 40.
40.
That means this is gonna be here. Wait, this one. Okay. But, okay, so 40 is your equivalence point. So now your half equivalence point is 20. And what is the pKa again?
4.9.
So at 20 should be 4.9. 4.9. So here, okay? And then you still start at the same amount, same, and do like that. Do you guys see how I do it? Okay? Very important. Very important. Very important. 3 points. You're going to get 3 points for this. 3 points out of 46. Out of 46, 3 points. Just a graph.
I have a quick question.
Mm-hmm.
When using M1V1 is equal to M2V2, right? So let's say M1 is like for the acid is HCl, and for base the formula is MgOH2, right? So that's two H, right?
Now that's not gonna work. Now M1V1 is not gonna work. Find the moles of one based on the balance equation. Find the moles of the second one. You do stoic, okay? M1V1 will not work for that. You do stoic, okay?
Why not?
Because it's not 1:1. Because it's not 1:1 ratio.
Yeah, so that's what I'm thinking. Like you can also just do M1V1 is equal to 2 times N2V2 because now there's two H.
Yeah, you can do that. You can do that. But because if you do not want to get mistaken where to put the two, you can also first find the acid, whatever mole you can, use the balance equation, do stoic moles to moles ratio,
And then just
find the other moles, divide by the volume. That's it.
Okay.
If you do
All right.
not want to mistaken, like where do you put the two? Do I put in the acid or in the base, right? So you can do that as well. Okay. I think that's it for this. Number 2. I need to hear your guys' justification for B. Do you have it, Saket, or do you want to ask question?
I have it.
Okay, write it down, send me the picture.
Okay.
Or are you doing, Anam? You're doing this, right? Okay. Ayana, you there?
Yeah.
Okay. You done?
Yeah.
Okay. Which is a stronger acid?
I said acid 1 was stronger.
Because?
Said it was because it has more electronegative atoms causing a stronger.
No. No. Because if they give you the evidence, use the evidence.
Oh,
okay. Okay, so because?
Because it has a lower pH at 0.01
At the?
molarity.
Correct. Now for B,
Okay.
which is a stronger acid? 2 or 3? Second?
I put that 2 will be a stronger acid because F will attract the electrons more, meaning that H will be like easier to give up because it'll attract the electrons more to itself, and the bond of OH will be more polar.
In terms of H, so that's okay. That's 1. Now what about the
Okay.
stability
Yeah.
of conjugate base?
I did not do that.
Once you once you guys release this, once you break this, right? Let's say there's none of this anymore. No. Negative charge will go to the oxygen. Now this negative charge on the oxygen, fluorine will, being a more electronegative element, it will be able to handle the negative charge. Okay, on its compound. So acid 2 is more in what more? So the conjugate base is more stable. So this is more stable. Okay, so the conjugate base is more stable. That means it's easier for the acid to become the conjugate base. Think you guys already know this, right? Which one you're gonna choose? Yeah, Inaya too?
I had a question for like, I think it was part A where it was talking about the pH. It was like talking about like, the pH, and you had to determine like which one was a stronger acid. So did you only just have to say like it was because of the lower pH that acid one was stronger, or do you have to mention like the electronegativity?
Oh no, you don't have, because they give you evidence, just like IMF
Okay.
as well. Just like IMF as well. Okay, sometimes they're gonna give you the boiling point of two molecules, ask you which one is the, unless they ask you justify and everything, right? I mean, you can first give the evidence, right? CEJ, claim which is stronger acid. So acid 1. Evidence, what's the evidence? The evidence is that acid 1 has a lower pH at the same, concentration. What's the justification? Now you can justify based on the bonding, blah, blah, blah. Make sense?
Okay.
Yeah, Saket?
Can you please explain Z again? I mean, like part two, double I, about
You mean the
the.
conjugate base?
Yeah, exactly.
So, okay, once you remove the H plus, right? This is your conjugate base, right? Whose conjugate base is more stable?
Acid two.
This one, right? Oh, you know the name? Okay. Okay, but anyway, this one, right?
Yeah.
The acid 2, you said. I heard acetone. Okay, yeah, acid
No.
2, right? This one will be more stable because the fluorine, being more electronegative element, are able to handle the negative charge on it. So because the
Okay.
conjugate base is more stable, the acid do want to get to the more stable.
Yeah, I understand that part. Yep. All right, thanks.
Okay. Wait, what I was going to... oh, okay. You guys know this, right? Yeah, Anam?
Like when we answer FRQs in general and they don't ask us to justify, can we just like write?
I don't think I can hear you clearly. If we are what? I'm sorry.
When we do like FRQ questions in general, like if they don't ask us to justify or explain further, should we just like write the answer and not like write
Yes. No justification. Do not justify. Do not waste your time. Okay, number 6. So you look at the what? Go ahead, do number 6. Half equivalence point. Sorry, blah, 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 my bad. Equivalence point, right? So it's around maybe 6, 5, right? Around there. So you choose the one that is closest to it.
Metal red.
That's it. Buffer. I think we also did. Oh, maybe you guys can do this. Go ahead, do 13.
Are we almost done?
Yeah. Just one more unit. That's it. That's the last. This is the last time you guys gonna see my face. I mean, except for those one-on-one students, but okay, in buffer in Henderson, I keep saying this, even though the formula give you concentration, use mole. Okay, in your conjugate acid, conjugate base, use mole. Because if you go with the concentration, you have to again divide by the same amount of what total volume. You're going to mess up. Just ignore that. Okay, just use mole. Do it. Very important question.
Can I reference this with the Henderson-Hasselbalch equation? Like say like, it cancels out and stuff.
Yeah, write your answer. Mute yourself, Madam. Sometimes justification does not need to be in words. Like the Q. Okay, so we know that a student wants to prepare a buffer of this, starting with this. And the pK is this. The student has excess of this. That means this is your conjugate base. How many ml of that must be added to this? So what do you need to do? You know that they actually want the what? The pH. And so you can start what? pH equals to pKa plus log of conjugate base over conjugate acid. If you want the pH equals to pKa, your conjugate acid and base should be the same, right? Of course, they're talking about the concentration, but the best way to do it just using the mole, okay? Now, you want what? The final concentration of the conjugate base and acid are to be the same, right? Or actually the mole as well. It doesn't matter. Now, because you can find the moles of what's that? 0.075 mole, right? And okay, there you go, right? So this is also 1 molar. That means you divide this by 1 molar, a mole per liter. You're gonna get again 75 ml. So you're gonna need 75 ml of this. If you can show your calculation, that's fine too. And then you can write a line about that. Okay. Weak acid, we do not break. Rewrite it. Strong base, we break. What type of, if we are about to find the pH, what do we use, ice or BCA? Oh, Henderson. And Anish? What do we do?
BCA.
Ice, good, BCA. And then you find okay, how many ml of KOH must be added? Now you just do BCA, right? So you do not know the mole of this, that's okay. Of this, so that's a what, 0.1 to prepare a solution, and then let's say this is to prepare a solution of buffer. So this is 0. This is you do not care. So if you want to prepare a buffer, wait, Madam, that means what? And the buffer has the same as pKa. That means finally you want this and this to be the same. That means this should be 0.05. This should be 0.05 mole. Yeah? And to get that, that means what? This should be 0.05 mole. So then this is going to be minus 0.05 minus 0.05 plus 0.05. And this is 0. That's how you create buffer. So 0.05, most of that means what it will be the volume, around 50 ml, if I'm not wrong, right? Yeah, 50 ml. Okay? Make sense? Yes or no? Yeah? And then buffer capacity. Yes, Inayat?
So, anytime they give us like a weak acid or a base and then its conjugate pair, we use the Henderson-Hasselbalch. And then anytime they give us like the weak acid or base and then like something that's like strong, we use the BCA table.
Yes. And if they only give you weak acid, nothing else, you do Ka with ice stable. If it's on the weak base, you do Kb with ice stable. You react it with water. We did it, right? In the ice table in the first question of acid and base, where they give
So
you
then,
the pH.
so then you'd find like the negative log of the Ka, or is that just in general? Okay.
Negative log of the H plus to get the pH. Anderson. Well, buffer capacity, you guys understand, right? The more amount of conjugate acid base you have, the more resistant it will be for the blah 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 for resisting the pH. Okay, last unit. That's it. We're done. Entropy. Everyone knows, right? What is entropy? Entropy increase or decrease? Increase or decrease? Yeah,
Decrease.
Because going from gas to solid.
Yeah.
Okay. Okay. So well also it's negative anyway. Okay. Also you guys understand, right? How to use this. Again, this one, remember yesterday? Make sure to show the formula. If you do not want to miss any point, show the formula. Okay? Product minus reactant.
So you just like plug in the values and just get like the delta S, right?
But make sure to show the formula. Yeah. Okay, this is important. Go ahead, number 7. You have delta H sign, delta S sign. Figure it out. Rajin, do it. Okay? Yes,
Yeah, I'm
Sharwari?
doing it.
Can I say what the answer is?
Okay, yeah. What you got?
Isn't it C?
No, it's not. You have to figure out using this formula. For a reaction to be spontaneous, delta G should be what?
Negative.
Negative, right? Now, you do have the delta H to be positive, right? And then you separate this like that. Delta S is positive too, right? So if you do want to get the delta G to be negative, right?
It would have to be the opposite.
The temperature should be high, because this part is the one that's going to give you the negative, right? So this one has to be high, right? So at high temperature it's favorable, low temperature unfavorable. What is it, Madhav? Do you want to answer?
Yeah, I was about to say B.
Saket? Question or
Yes.
answering?
No, I think it was B.
Okay. Make sense? Anish, we're almost done, promise. This is such a easy point. Okay, please do not lose point on this. Yes, Anam?
Wait, but do we need to like think about like it says that assume that they don't change the temperature, but just that now in a minute.
Wait, I really can't hear you.
It says assume that delta H and delta S don't change the temperature.
Don't change in temperature? Oh yeah, they do not.
Yeah.
Okay, yeah, they do not change. So this is stay positive, this is stay positive, right? So how do you get a negative delta G? You have to make sure this part is the highest, right? Because it's negative. You want this to be negative. So this part has to be very high. Because let's say this is 5. If you have this is 3, it will be positive. So you want to make sure if this is 5, you have to make sure this is maybe 10. And how do you get it 10? If you increase the temperature.
Okay, yeah.
The more you yeah.
So the reaction is spontaneous at high temperatures.
Yeah.
Okay.
Then product minus reactant, blah, blah, blah. Remember, delta G has nothing to do with the speed of the reaction. Just because you're the... Is there any question on them? No.
What do you
Delta G... What?
Wait, what did you just say? I didn't hear it.
No. Oh, no. I'm just going to re-say it. Okay. So if you guys have delta G negative 773 kilojoules per mole. Question. Does it mean the reaction is fast?
Doesn't it only mean that it's thermodynamically favorable?
I was about to say that.
Correct. Okay, it's not, doesn't mean that it's fast. Okay, it doesn't mean it's fast. It is just thermodynamically favorable. Okay, it has nothing to do how fast it is, okay, because how fast it is has to do with catalyst, activation energy, okay? And then we also have this formula. Do not forget, in this formula, reminder. Let's see who remember. What should be the R?
0.08314.
0.08. Oh. Araf, what's the
No,
R?
I'm not sure.
You're not sure?
Like when you're like converting it, it's gonna be like that, right?
Isn't it
Inaya,
like 8.3
your
or something?
conversion is wrong. Your conversion is wrong. See, delta G will be in kilojoules. The 8.314, this is in joules. Okay, Madhav, your concept is right, but you're answering too fast. Your number's wrong. And then you do divide by 1,000. Okay, this is very important. You divide by 1,000, 0.00. Yes, Inaya too?
Oh, 2 zeros.
Is delta G always given in kilojoules?
Yes.
Okay.
Delta S, however, when you do delta G equals to delta H minus TS, the delta S is always going to be in joules. Again, please listen. You have to go convert the delta S into kilojoules before you plug it into this. If you do not convert it into kilojoules, you're going to lose point. You're basically not going to get any point. Okay, make sure to convert delta S to kilojoules. Okay. What's the R again? Araf, now do you know or do you still not know?
It's 0.008314 kilojoules per mole.
Good. Not kilojoules per mole. You can go back and check the unit in the reference sheet, okay? Okay, now this one we already talked about, right? If delta G is negative spontaneous, K would be more than 1, E will be more than 0. Okay? Make sure to remember this so you don't have to think too much about it. Okay, what just happened here? First, they manipulate the K, right, in this question. Go ahead. Find the new K. Everyone, find the new K. What's the new K? Anish? What's the new K?
I got 2 times 10 to the third.
Okay. Now, because the K is what? Larger than 1, delta G is negative. Okay? Okay. Did everyone got 2000 as your K? Okay. This one is just what? See, they give you each of the delta G. You do what? Product minus reactant. Okay. Almost done. Almost done. Okay. Electrochemistry. I really do not want to do this, but okay. Do this first.
Wait,
Take a screenshot of this. Do
I
you
have
have question, madam?
yeah, like so like remember like there's like these half equations, right? So like for the half equations, there's like a voltage for that, right? And like you gotta like flip it.
Mm-hmm. Do it. Do this. While you're doing, you're gonna remember, and then you can ask questions. Take a
Yeah,
picture of this.
I'm trying to ask like which one do you flip? Like is it like the bigger voltage or the smaller voltage?
If it's galvanic cell, the smaller one.
Okay, small.
If galvanic cell, smaller one, which is this one, the galvan. If it's electrolytic cell, it's the bigger one.
Okay.
Take a picture of this, guys.
Just I'm just gonna go to the bathroom real quick.
Take a picture first. Okay. Take a picture of this. We're almost done. Take a picture. And do it. Anish, do it. There's only 3 topics I want to go over, and that's it. Probably another 20 minutes, Inaya. 20 minutes, that's it.
Miss Frida,
Mm-hmm.
can you go down to the page when taking the screenshot? It didn't come out nicely, so.
Oh. Is this fine?
Yeah.
You can take 2 different screenshots then.
It's fine.
Okay.
Thank you.
Okay.
I have a quick question.
Mm-hmm.
This is unrelated, but for KSP, we just have to find when it says find molar solubility, we're just finding X using the ice table, right?
It's stable.
Oh,
If they're asking you product solubility, that's KSP itself.
So like based
Okay.
on like the thing we did, right? It was like X and then like for
Okay.
the lead and then like the 2Br minus, right? So whenever there's like a coefficient next to it, it's always gonna be like 2X.
Yeah, normal ice stable, madam. Normal ice stable, yes.
And then you just plug it in and stuff, and then like
Yep. Yep.
all right.
You got
Oh,
it.
wait, I didn't see what you were saying about the product solubility. being just
Well,
KSP.
product solubility is the KSP. It's just another
Okay.
name of it. So if let's say that they give you the solubility, that means they basically gave you the X. You plug that X into the KSP formula, find your product solubility, which is basically just asking you to find KSP. That's it.
Okay, that makes sense. Thanks.
Miss Frida, can you scroll down? My
Yeah.
screenshot didn't come out. Huh?
Sorry, yeah.
Okay, thanks. Yeah, got it.
Really easy question, no? This one? Send your work.
Wait, I have a question on C. So like the salt bridge, right? So like the salt, should I put like the like so like for example, like I could put like the K on like all the K particles on one side and then the NO3.
Just draw one. Just draw K plus
Mm-hmm.
and NO3 minus. Show the direction, left or right.
Okay, got it.
Anish, you're done or are you sleeping?
Question 1, right?
Yeah. A, B,
Yeah,
C, D. You're done?
I finished it.
Okay, let's do it. Okay. Which one get oxidized? You have to find the oxidation number. And the one that increase in oxidation number oxidized. So Anish, which one?
The AL.
So what do we write in the balance equation? AL
AL solid goes
solid.
into AL3 plus 3 electrons.
What? N2 AL. I'm sorry, what? AL solid goes to
AL3 plus plus 3 electrons.
AQ plus 3 electrons. On the diagram galvanic cell, draw an arrow show the direction of electron flowing. So Al being oxidized, that means which is the anode, which is the cathode? Sumit?
Al is the anode and Ag is the cathode, and it's from anode to cathode.
So make sure to draw it on the wire. Okay? Okay, a solution of, okay, so the cation, the K plus will go where? The NO3 minus will go where? Yeah? Cation will go to cathode. And where's cathode? On the left. So cation will go to the cathode on the left. And anion will go to the anode on the right. Now, which one will increase in mass? Which one will increase the mass? Anode or cathode? Anam?
Cathode.
Cathode will increase the mass, so Ag will increase the mass. Good job. Okay, electrolytic.
Wait, can I tell why?
That's okay. You're good. Do number 2. I want to release you guys soon. I know everyone's already tired. Inaya's crying inside. The tears not coming out, but she is crying. Inaya, to your doing. Can I see your paper? You're doing? Okay. I want all of you send me a private text on the Zoom chat or maybe on the WhatsApp telling what's your current grade in your class. Please. What's your average grade in AP Chem class? Except for, oh wait, she's not here, is she? Tuisha is not here? She's not. What, Anish?
Wait, like overall average or just like for this quarter?
Okay, both.
All right.
Okay. Those who are doing very well in my desk is the ones having 4 grade. Depends on the teacher, that's the thing. Someone's gonna say, oh, I have 98, 99. It's, yes, Inaya, too.
Oh, I can't see my grades.
Oh.
Like
Oh, that's weird.
cause whenever like the quarter ends and the quarter just ended, they like close your grades. Like you're not able to see them. I don't know why.
Your quarter already end? Oh, you mean what about this quarter?
Cause the I don't know, it's quarter 3 ended, so quarter 4 starts like at the beginning of May. But like you can't see your grades, like your entire grades for the school year.
That's an improvement, right, Rajin?
Um,
Compared to the first quarter?
yeah.
Okay. Well, there's like for Sanvika, I don't know if you guys know her. Well, who's not gonna know Sanvika? For her, if she got a 5, she will get A plus. If she got so her class grade is based on her score for the AP test. So if she get a 4, she's gonna get an A. So that's so cool. You guys done? Let's do it. Okay, so we know that we want to be able to produce, whenever you do electrolytic cell, make sure to read the question, okay? So you see that you want to be able to produce Cl2. That means this one, the Cl2 in the reactant, you have to flip it. Okay? Becomes Cl2 plus 2 electrons. So if you flip it, delta E also gonna be negative. And then this one stay the same because you want to produce zinc, right? So the E naught, oh, what are they asking? E naught, right? So you can just this plus this. That would give you negative what? Someone? Negative 2.12 volt. And then you add this with this. And Cl2 plus Cn. Okay, and then for D, draw arrow. Again, for arrow, it goes from where to where? Anode to cathode, right? So which one is your anode? The Cl minus, right? So electron goes like that. Of course, draw on the wire. Okay, electron. And then based on B, would you apply, if you apply this voltage, is it going to be sufficient? No, you're going to need at least 2.12. Yes, Sakib?
For a electrolytic cell, what do you flip?
So usually you're going to flip the bigger number.
Okay.
Okay, but always read the question. Always read the question because the question gonna give you the hint. What do they want to produce? In this case, they want to produce Cl2 and the zinc. So do you see how the Cl2 is on the reactant now? If you want to produce it, you have to flip it. That's why we flip it. Okay, but here the zinc already on the product, so you don't have to flip it.
Yeah. All right.
Okay.
That makes sense.
Can you scroll a little bit down? Yeah, thank you.
And this will not be enough. You need 2.12. Okay. Make sense?
For E, is it also like because it's more negative, or is it just because it's not 2.12?
What?
For like part E, is it because like 1.4 is not close to 2.12, or is it also because it's not negative?
1.4 is not. Can you type your 1.4 is? I'm so sorry. I really cannot hear you. One. I do want to be able to really understand your question before answering. Now, it doesn't matter, okay? The negative here, the negative just tell that you have to apply that force. The word apply here, they say it's negative. But how much force you have now? You have 1.4. You need to apply what? 2.21, 2.12. That's why it's not enough. Okay? Does it answer your question? Yeah? Okay.
Because you need 2.12, right?
Minimum. Yeah, the negative just said that you need to apply that. Okay. The last one I want you guys to do is to be able to do this. Number 6. That's it. And we're done. We're done. Right now, the best course of action for you guys, if you want to study how you would study, you do the all FRQ questions. Okay? Do the all FRQ questions and then look at the scoring guide, which is very important. This is the most important step. Look at the scoring guide, not just like to look if you get the same answer. Read each point, where does they give the score on? Okay? So you will say, oh my God, I got this right, but because I did not write this, I lose a point. Okay, so if you want to study that, I would recommend, I don't think you should be going over, unless you still do not remember your geometry, hybridization, angle, then yeah, sure. But you just have to, if you already remember the things that you have to remember, in one day, if you can do 2 or 3 papers, which is, if possible for tomorrow, do those. Okay, and practice your timing. Well, I don't think you guys will have any problem for the FRQ. The multiple choice is different question, right? Because, yes, Madhav, go ahead.
So like the Faraday constant, right? That's in coulombs, right? Just
Yep.
okay.
So for Faraday constant, it's what 1 mole of electron is 96485 coulomb.
Okay. And like amps is basically coulombs per second, right?
What are they asking you? Mass. Why would it
Yeah,
be
I just
coulomb per
want to like know
second?
the conversion. That's it. I'm just like
Yeah. And then whatever ampere they give you, you want to convert that ampere, 5 coulomb equals to 1 second. And then just do the math. Just do the stoic.
Yeah, that's what I was doing. I just need to like clarify on that. That's it.
You done, Saket? Or do you
Yeah,
have
can you
question?
confirm if this is the answer? I sent you
Yeah.
something in chat.
Okay, on the chat. Correct.
Wait, is it? Sorry.
It is correct.
All right, thanks. They would accept it, right? If I use a different method. I use this equation that lets you calculate.
That's okay.
All
They
right.
will accept. Good job, Anish. Yes, Sumit, you can put, you do want to answer, right, Sumit? A question.
I also have a question, but it's not related to this.
Go ahead. What's your question?
What's the minimum to get a 5?
78%.
Okay. Yeah, because like I got an 81 with the combined score on my MCQ and FRQ I took on Saturday in school, and apparently that was like barely a 5, so I just wanted to clarify.
Okay, so that means what? That means is that like how was the test was conducted? Was it online? How was it?
The MCQ was online, and the FRQ was in like a paper booklet.
And the questions were on the
The
online.
questions, like the answers for the FRQ?
No, not the answer, the question. Was it like the College Board questions or was
Yeah,
it
they
like
were
your
on AP Classroom.
AP Classroom? Okay, that's good.
Yeah.
Okay. Also, tomorrow, guys, sleep early. Okay, sleep early tomorrow. And then what else? Make sure to breathe, okay? Take a deep breath before the AP test. before you like you just be on the zone. Okay, and if you're stuck with the question just because you feel you do not know, doesn't mean you always not know it. Okay, so skip that. Do whatever you can, even in the FRQ. Okay, do not think about what you missed. Do not make, oh my God, I will not know that, and ruin the other questions. You do not need to get 100 on everything. Okay, you just need 78% to get a 5. That means what? Whatever you, and do not skip any question, FRQ, MCQ, whatever, do not skip any question. Okay, and do not just because I said do not skip. Oh, you do not know how to do this. What did you do? Oh, I'm going to put 1 gram. Oh, this is just stupid. Show some work. Okay, you can know at least how to what? Maybe convert this into coulomb, right? And then convert. Okay, I'll go over this first, and then we're gonna. You start. We already have 2 relations. So yes.
I'll put my answer private commented too.
Okay, I think that would be right. But okay. So second, this is the ampere always convert to coulomb second. Coulomb second. Yes, Inaya?
They gave like half points, right? On the FRQ.
If I'm not wrong, they do not. Do they? I don't think they do.
Okay.
Okay, and then second cancel out. But if you have 2 points, they might give you 1 point. Okay, so yeah, coulomb. You have coulomb. Now from here, you do what? 96485 coulomb, 1 mole electron. And then what? How many electron is this? Look at the oxidation number. From 3 to 0. That means in 1 mole of AU, you transfer 3 mole of electrons. So 3 mole of electron on the bottom, 1 mole of AU, and then molar mass of AU, which is 197. It's around 3.15 grams of AU. Okay. Do not skip questions on the FRQ. Do the 3 rounds method on MCQ, which I already talked about, right? Last time. And then whatever, so for example, FRQ, okay? Maybe you see something that, oh, you cannot get your head onto it, just skip it, okay? Move to the next one. When you come back, usually this happened to me. When you come back, then like, because your brain has warm up enough, and then something will come into your brain. Oh, okay, we did that, we did this, maybe I can do this. Try something. Okay, try something, not a random number, but something. Let's say, for example, this question, right? You do not know. Wait, let me see different. Okay, maybe this question, you need the E. You need the E to, let's just say you need the E to find the delta G or something. You do not know how to find E. Then what do? Just use a random number, show your work everything to find delta G if you know how to find delta G. Okay? They will not carry on your mistake. Okay, so your job tomorrow is not to be perfect. I mean, like Tuesday. It's not to be perfect. It's that you want to at least do as best as you can. And do not get panic, okay? Questions, I know some students like, get panic so easily. Do not do that. Sleep early. And also try to meditate before the test. And also manifest. I know for sure all of you are capable of getting a 5. Okay, or at least a 4. At least a 4. I think I already trained you very well to get a 4. I have students last year who I pretty sure he's gonna get a 2. He got a 4. Okay, so when Inayatu was asking me, what is the score for getting a 3? No, Inaya, you should be aiming a 5. Okay? not a 3, a 5. So all of you, I want you to be aiming for a 5. And just make sure, get some rest, sleep early tomorrow. Do not overthink. Do not overthink question, especially Madhav. Do not overthink question. Just make sure, just believe that you have everything you needed for the test. You know everything you needed. We've basically gone over everything you needed for tomorrow. Okay, there's nothing that you do not know. It's just your job is to be able to decrease the amount of silly mistakes you're making. Okay, make sure recheck your answer if you have extra time. And for the MCQ, do it 3 rounds. The first round when you're doing, just go over it, see which one you can do fast. Second round, come back, do the calculation 1. That's going to take some time. And then third time, come back to the question that you actually cannot do. Do not get stuck 3 to 5 minutes on a question. Do not do that. Okay, any other question you want to ask me?
Yeah, what's the best way of like calming nerves before the exam?
Okay, so what I would recommend is, of course, no coffee. Okay, no coffee. If Anish is, well, Anish is laughing. You consuming coffee? No coffee, because coffee makes you so anxious. Okay? Get enough sleep. I know some of you, probably some of you like so stressed out that you couldn't sleep. That means what? Tomorrow, coming back from school, try to get some exercise. Make your body tired, okay? Get some exercise, make your body tired so you can sleep early tomorrow.
Yeah, that makes sense.
Okay? And then what? And then in the morning, you can wake up early in the morning. That works for me. Wake up early in the morning. Okay, and then whatever review you need to review in the morning. You want to review some of the notes, some of the cheat sheet or whatever you want to review it in the morning. Okay? Whatever studying you want to do, just study tonight. You don't have to study anymore tomorrow. Do not study tomorrow. Okay?
Okay, should we do like practice questions tomorrow or something?
I mean, I guess you can, but do not make yourself stressed out. Whatever you want to study today. Practice question, everything, doing the scoring, which is already late, but still.
Yeah.
Okay? And tomorrow, just make sure you get enough rest. Okay? And there's one more thing I want to say. I don't know, this might sound silly to you, but it always worked for me. I want all of you go, I'm actually gonna send it to the chat box. Okay, I want you guys to download this picture. I'm a big believer of manifestation. It has worked tremendous for me. So I want you guys to put this as your wallpaper on your phone. This is what you should be looking. Okay, this is what I know. It sounds so stupid, but trust me, and you have to believe it too. You have to believe it too. If you do not, it's not gonna work. Okay, you have to believe on July, whatever July, when you open your computer or your phone to check your score, this is what's gonna come in.
I like that.
I mean, like, I promise you, I have this type of incidents where it's 100% I'm not gonna get it, but I manifest and I really get it. Okay, so please do it. Put it in your photo gallery and put it on your wallpaper. Make sure this is what you're gonna see for the next few days. I mean, like up to the AP Chem. Okay. And okay, I know you guys think she's so lame, but there's a science behind it too. It does something to your brain when you do that. It activates something. Okay? So your brain is going to make you get that 5.
So the activation energy.
It's not activation energy. Activation energy going to prevent you to go somewhere. The higher the activation energy, it's harder to go, right? Activated breath or something. I do not remember, but it worked. Okay, so keep that in your wallpaper. That's what you're gonna see on the result day. Okay. Anything else? You got this, everyone. You got this. And if there's one thing I want you to study, is just go do past paper, go over the scoring rubrics. That's it. Okay, I don't want you to, oh, I didn't study this, bomb calorimetry, blah, blah, blah. You don't need those. Okay, no new information. Okay, no new information, just know how to. Okay, see, Anish, see, you have to speak up, Anish, so they can see your camera.
Yeah.
See, Anish already put it on his. That's what we want. That, yay! Good job, Sharvari. I know you guys gonna make it. And then once I'm done, whoever got a 5, I'm gonna interview you guys. Okay? So you're gonna be popular, I guess. Okay, go get some rest and keep studying if you still can. But yeah, bye-bye.
Thank you.
All right, thank you very much.
Bye.
Thank you.
Bye.